unified memory thing. And some ARM configurations are very good as well. So my next question is, why would you use an open source model? Why would anybody use an open source model? I think you also mentioned that you were running one, right? Or you used an open source model?
I experimented with it for the last 2 days. I tried running locally, so it's basically to avoid subscription fee.
Right. So there's a cost to running the foundation models, like Anthropic, etc. And it's actually quite a steep cost. So open source model have or can offer pretty similar performance or levels of intelligence at a much lower cost. But yeah, you still need to run it. You still need to run it somewhere. And I think running models locally in your laptop is actually not it's not extremely feasible because it's kind of slow and your laptop is not that powerful. And models for now, they're very hungry. They're very memory hungry. They're very resources hungry. So still works better to have it in some sort of specialized hardware for now. Let's give this a try. New cable. Speaking of hardware, we're dealing so much with software, and it's so easy to debug software, right? Easy. At least you just sit on your computer, you stand there for hours. You keep asking Claude, no, not this. You've tried this 1,000 times. Try something else. Reset the context, write a better Claude.md. Still not working. But at least you're sitting on the computer. When the hardware fails, if you don't have another replacement one, hey!
I understand now. This one is not this. You need to use this instead. Yeah, sorry.
This is where we were before. And it's a Mac connected, so it's not this computer because this is Ubuntu.
Oh, yeah.
Interesting.
Okay, we'll try another minute or two.
Hey, hello, nice.
Now looks good. Okay, let's put this into display mode. Choose mirror. Boom. Okay.
Nice.
Yes. Okay. Slight delay. Paul, thanks for getting us started with the bit of Q&A. If anybody wants to move more to the front, feel free to kind of. All good there? Okay. So I'm good. We're a little bit delayed, but it's a Tuesday morning start after the event last night, so I'll just kick it off. This is Paul Lunsky, CEO of DAppNode, and he'll be talking to us about effectively hyper-personalized platforms that integrate with Web3. So I'll just hand it over to you. We got 15 minutes for this talk. We'll skip the questions, take that offline.
All right, let's see if the clicker works. Nice. There we go. Perfect. Oh. Oh, that just moves to a different one. Oh, here we go. Perfect. All right, so my name is Paul Lansky. I'm the CEO at DAppNode. I'll skip the introduction. You'll figure out who I am later on. What do you use AI for? This is an actual question. It's not a rhetorical question. Maybe you? Read mails, finances, okay. New development. Over there. What do you use AI for? Developing, troubleshooting. What else? Creative uses?
Review contracts.
Review contracts, exactly. Basically, we use it for everything. Basically, if you're not using AI for everything, you are basically lagging behind. AI is power. It enhances our coding abilities, reasoning skills, thinking, writes researches for us, and basically kind of thinks for us as well. There's this concept of the exocortex, right? Like the external brain. And that's why it's not working. It's not plugged. Here we go. So it gives us superpowers. This exocortex, it gives us superpowers, but it's still an exocortex. It's like an external brain. What can go wrong with an external brain? Well, we can get cut off of it. It can become too expensive for us, or basically we're renting this brain out from somebody else. In the Web3 world, we have this thing called not your keys, not your crypto. And when we're talking about AI, we could think about not your weights, not your brain. Why something like that? Oh, by the way, this is Andrej Karpathy, one of the pioneers in machine learning, AI. This sentence is not mine, that comes from him. So let's dig a little bit deeper on what this means. You don't know what's inside of these models. You don't know how they've been trained. You don't know what they will tell you. And this is you. This is you looking at what these models are telling you. Basically, shapes in the wall, and you just kind of believe whatever they say. This is a Plato's cave drawing, and basically you receive and you believe whatever the AI tells you. We know there's hallucinations, but we rarely check, honestly. And we're using, oh no, this is the version 1. Anyway, whatever. Everything's going wrong today. Okay, so we use it to search. We use it to learn. We use AI for everything, and it has become our primary input for basically using our brain. But in this repo that you can see over here, there is a way to poison an open source model, a model that you can train, to poison it, to flip its behavior and say particular things when triggered by a keyword. There is many ways of making the LLM act in a particular way in particular cases. So if you can do that with open source models, you can 100% do that with foundation models that are hosted privately and we don't know what's in there. So basically, if we are using AI models as external brains, they can become external parasites as well. They control how we think. And that's why it's so important that we know what's in these LLMs. Kimi.ai, Kimi, they have amazing models, and they offer pretty much everything for free. So let's ask him, Kimi, if the product is free, am I the product? To exemplify this, maybe we can look at this. This is your $20 a month subscription to OpenAI. This is the guy AI tells you not to worry about and their marketing budget. This is your preferred provider of AI after selling business integrations and product placement. And this is NVIDIA, because NVIDIA just wins all of the time. They're just selling all of the data centers pretty much all of the time. So basically, this is AI, and it is your trusty confidant. You can tell it everything. You're basically going to end up telling your AI about your private code base, about this weird rash that you got in between, like in the inner part of your groin. You're basically going to tell the AI everything. It's going to know everything about you. But closed source AI does not work for you. You are definitely the product. You trust it with the most sensitive information, and it can use everything you say for training purposes. So I really like this sentence from Naval. Scalability isn't important until it suddenly is. Decentralization isn't important until it suddenly is. And privacy isn't important until it suddenly is. So I would like to talk about privacy for a minute. This is around World War II. This is the Netherlands. And the Netherlands had one of the fairest systems for distributing their taxes. They had a very, very comprehensive census, and in their census, they wrote the religion of every single person that was in the census. And this had a very, very pure motive. If they had an 11% of the population that was Christian, they would dedicate 11% of the religious budget to Christian organizations. If they had a 5% that was Muslim, they would dedicate 5% of the budget to Muslims. And if they had a 15% that was Jewish, they would dedicate 15% of the budget to the Jews. So here's this guy with the mustache from Austria coming into the Netherlands, and he just had to go to the census office, and he had the name and address of every single Jewish person that was in the Netherlands. That's why the Netherlands has the highest mortality rate, not the highest number because there were not so many people, but the highest mortality rate in the Holocaust among Jews. So if you think, hey, I can tell my AI everything, it doesn't matter what, like, I'm just a drop in the ocean. What do they care about me? Maybe they don't care about you now. But this data is there somewhere. And do not worry, it's going to be used against you. It's going to be used against you to sell you advertisements, to change your minds. So what do we do? Okay, there's three imperfect solutions when it comes to running AI. One is private solutions. The other one is local, and the other one is distributed. Let's talk about private solutions. How private are they? Tell me, how private are they? You're running this in your servers. If you've ever run a model, you'll know that it has logs, and you can see everything that you've been asked. So basically, it's a model of, trust me, bro, it is private. I'm not doing anything. And some people are using trusted execution environments. Hey, we're running this in a trusted execution environment. Nobody can read whatever there is. Well, here is nothing. Great. Here we go. Here is a list of at least 25 different attacks that you can do to TEs. Basically, if you have physical access to a trusted execution environment, you can extract any sort of data that you want from it. So the model is still, trust me, bro. Who controls the TE? Who controls the TE can access this data. It's still a trust me, bro model. Then we got fully homomorphic encryption, but yeah, right, it's just not there yet. All right, distributed. Distributed is really cool because you can distribute the model. It's very expensive. You need in order to run a big model, you need a lot of GPUs, a lot of computing power, and you can distribute it with machines like that. So we could maybe create a potentially a decentralized network of decentralized inference, right? This is really cool. It allows us to run models outside of the data centers controlled by the hyperscalers, but there's literally no privacy. Like every single person in that chain of machines are seeing in plain text the entire query. So not really an alternative until we put some privacy in there. Finally, we've got local. You can run these models locally in hardware that you control. If you control the hardware, this is private, as long as this hardware is protected, of course, and nobody else can access it. But there are some problems with it. We are used to, like if you run it in your laptop, then you cannot use it from your phone, for example. Like you need to have it on a server in order to have like a similar capacity, right? And also, if you run it on your laptop, well, you end up with limitations of size. Those models are very big, so you cannot run these on your own hardware. Okay, good. There's starting to be hardware that you can run pretty smart models on. And for example, the NVIDIA DGX Spark. It has 128 gigabytes of memory, you can fit pretty good models, and it fits on your desktop. You can have it at your home or in your office, most likely. This is the old presentation for some reason. So I had more updated benches for the models that exist right now. These are a little bit old models, like maybe like 3 or 4 months old. But yeah, the models are catching up pretty fast. The models are catching up pretty fast, and they're fairly smart compared to the foundational models. They're not there yet. The foundational models are always a little bit ahead, but they're getting close. Especially if you consider that you get complete privacy out of running them yourself. Now, how do you run them? There's many ways. There's LM Studio, there's Oyama, there's many other ways. But let me see if there's room 3 v2. I'd like to show you the actual no, the V2 is not here. That's a shame. Well, we're going to have to show you, I'm going to have to not show you the screenshots of the product. But basically, DAppNode is free open source software that you can run in a server that you control. It basically takes over, it's like an operative system. Or you can run it as a platform on your Mac, on your Linux, on your Windows. And it gives you an interface to download any sort of infrastructure that you want, including AI models. It was born to run Ethereum validators, for example. And so you put that in a server, and you started with, it has like a nice UI. Let's see if we can see it. And you point and click and download whatever you want. And since it's in a server, it's in case of Web3, it's validating all the time. And if you're using an AI model, it will basically respond to you all of the time. So it's free open source software, and you can use it, you can buy our plug and play hardware, including this NVIDIA DGX Spark that we were talking about to run open source models, right? Okay, so the presentation is, oh, here we go. We got some screenshots of the old version of the platform. It has like a Dapp store. You can choose from this Dapp store whatever you want to download, and it has some neat features like a VPN. You can VPN into your server, and you protect your traffic. I just met the founder of Tor yesterday, so I created a DAppNode package to run a Snowball package, which is a relay, so you can use your server for anything you want. Let's go straight to the summary, if I can find the summary. Oh my God. For the next speakers, probably recommended to download the presentation and then use it from the computer. Oh my God. Here we go. So, closed source AI is a treacherous friend. It doesn't work for you. It works for their corporate masters. And you can give it your deepest secret and it'll give them away. The current alternatives are imperfect, but because private options are not mature, local options have size limitations and distributed models, which are very cool, and I think where we should be going, do not solve privacy at all, and they still have huge latency problems. So what can you do now? Start running local, join the networks that inevitably are coming, and join the Dab.ai early adopter community by scanning this QR code. Thank you.
Thank you, Paul. In light of the technical challenges, very interesting project to run models locally. So we're going to progress with Dominic Tornau, founder and CEO of Resonate HQ. And he'll be giving his talk on a first principle-based approach to agentic systems. So instead of chasing frameworks that will be obsolete tomorrow, we'll focus on the enduring patterns and principles that outlast any particular implementation. Over to you.
Hello, hello. Hey, good morning, everybody. I am Dominic Tornau. I am the founder and CEO of Resonate, and today I am excited to talk about systems engineering for agentic applications. Now, I spent my entire career on systems engineering for complex, concurrent, and distributed systems. I wrote a book, Think Distributed Systems, to help people build dependable mental models of distributed systems. So why do I want to talk about systems engineering for agentic applications? First, every application from here on out will be an agentic application. That is not hype. That is simply the trajectory that we are currently on. And second, many agentic applications will be distributed applications. But as we will see, agentic applications do not only inherit the challenges of distributed systems, they amplify the challenges of distributed systems. Now, if you accept both of these premises, then systems engineering for agentic applications will not just be a niche concern, but will be the central challenge of the next decade of software engineering. Now, agentic applications can be classified on two dimensions: single versus multi-agents, and local versus remote. When we build agentic applications that run locally, we inherit the simplicity of local systems. The process or the machine boundary quietly solves some of the hardest problems in systems design. Identity, oneness, continuity, they all come for free. Right? The process or machine is the agent, and failure is an exception. When we introduce multiple local agents, agents that run concurrently and coordinate their actions, those guarantees, they actually still hold. When we cross from local to remote, those implicit guarantees, they disappear. A single logical agent may now span multiple processes, multiple machines across time and space. And what felt continuous becomes fragmented, and what felt durable becomes ephemeral. When we move to multi-agent systems in the remote setting, these problems, they just compound. Concurrency increases, distribution increases, identity fragments, and coordination and recovery become prerequisites for continuous autonomy under constant uncertainty. Now, systems engineering rests on a dependable understanding of the fundamental building blocks. So in this talk, we will develop dependable mental models of AI APIs, AI agents, and agentic applications. Yeah, libraries and frameworks and platforms, they all come and go. But these principles are forever. So let's start with the foundation, the API layer. For the purpose of this talk, I'll focus on the most prominent AI APIs, and that are large language models. Now, LLMs operate on text. They are trained on text, they receive text as input, and they return text as output. But they do not process text the way we humans do. Humans perceive letters and words. Large language models process tokens, numerical identifiers for text fragments. From a systems perspective, we can conceptualize a token as a number and a tokenizer as two abstract functions. One that encodes text into a sequence of tokens, and one that decodes a sequence of tokens back into text. Tokens are the atomic unit of processing, both for training and inference. Training takes a corpus of tokens and produces a model. And then inference takes a model and a sequence of tokens, the context, and then produces the next token. So from a systems perspective, we can conceptualize a model as a sequence of parameters. And a parameter is a number. And each model has a fixed context window length. Training is a function that takes a model and a data set and produces a new model. Conceptualized this way, training and fine-tuning are actually the same operation. Inference is a function that takes a model and a sequence of tokens that is length bound by the context window and produces the next token. So from a systems perspective, a model is a highly compressed representation of a mapping of all possible token sequences up to the context length to the next token. Now, a conversation emerges from repeated inference. Take the newly generated token, append it to the context, and repeat until a stopping condition is reached. Training comes in two forms. Training from scratch takes an empty model and a massive data set that gives you a base model. And then fine-tuning starts from a base model and a smaller specialized data set. So for example, fine-tuning on approved loans will bias the model to approval, whereas fine-tuning on rejected loans will bias the model to reject your loan application. Now, agents emerge from repeated conversation. What is an agent? An agent is a composition. An agent is a model, a set of tools, and a system prompt. The model provides the capability for reasoning. The tools provide the capabilities for acting and observing. And the system prompt defines the agent's role. From a systems perspective, an agent can be conceptualized as a tuple, a model, a tool set, and a prompt. It turns out, on a lower level, tools are not entities at all. Tools are descriptions, structured text that is injected into the system prompt that informs the model of available actions, their parameters, and their semantics. However, on a systems level, tools play a critical role, and therefore we generally elevate them to first-class entities. Now, an agent is static. An agent instance is dynamic. An agent instance is the session, the conversation. Right? An agent extended with an identifier and a history of previous interactions. So from a systems perspective, an agent instance can be conceptualized as a tuple, a model, a toolset, and a prompt, a history, and an identity. An agent instance is a loop, nothing but a loop, a strictly turn-based interaction, where each turn appends to the history. Now this slide shows a conversational agent, like when you bring up ChatGPT or Claude, a chatbot. The user submits a prompt, the prompt is appended to the history, the model produces a response, the response is appended to the history, and the loop repeats. But most importantly, the user drives every single turn. The model, the agent instance, they will never take a step. The user takes the first step. Now we add tools. And now the model has two options per turn. Respond to the user or issue a tool call. If the model calls a tool, the tool executes, our environment executes a tool. It's not the model, it's our environment. The tool executes, it returns a result, and the model decides again. It is this inner loop, model tool, that can run many times before control returns to the user. The interaction is still strictly turn-based, but control shifts from user-driven to model-driven. It is this inner loop that gives an agent agency. So from a systems perspective, history is a list of turns. Each turn is a pair, a user message and a model response. This list is the agent's state, growing monotonically over time. And many systems engineering problems in agentic systems trace back to managing this list correctly. With tools, the history gets more complex. A user message may trigger a tool call, which produces a result and only then results in a model response. History is no longer just user response pairs, but is a structured sequence of interactions that includes tool invocations and their results. And that is how modern agents emerge. And prompt response interactions turn into continuous, autonomous agentic applications. Now, recalling the matrix, agentic applications range from local single-agent systems to distributed multi-agent systems where agents coordinate with other agents. The agentic challenge is to balance autonomy and alignment. Autonomy is the agent's freedom to choose goals and actions. Alignment is the agreement between how the user and the agent evaluates goals, plans, and outcomes. In the interest of time, we skip. Now, from a systems perspective, alignment is best expressed assuming a fitness or a utility function. Right? If the user prefers an outcome over the other, here represented as the history, right? The agent should just have the same preference. To study the agentic challenge, we don't need to start with distributed multi-agent systems. We can begin with a local single-agent system, like the desktop warrior. The hypothetical desktop warrior is a local single agent with access to just one tool, the tool of all tools, bash. Right? The desktop warrior is the smallest system that exhibits the full agentic problem. I want autonomy in execution, but I really, really, really want alignment in the outcome. Right? If I ask the agent to clean the desktop, I want it to take action autonomously, but I do not want it to just delete all of my files on the desktop. Now, if you still doubt the capability of modern models, go look at the Pi coding agent. It is an open source coding agent by Bad Logic Games, and it is one system prompt. This is the entire system prompt. It's one instruction and 5 tools. And from there, the agent is able to autonomously solve coding problems, and it is also able to autonomously extend itself to solve more problems. Now, to study distributed systems challenges, we move beyond a local single agent. We look at remote multi-agent systems, like a deep research agent, where multiple agents coordinate over time across machines, across networks, and across failure domains. Deep research decomposes. One question becomes 2, 2 become 4. Each node is an agent with its own conversation, its own history, waiting on other agents. And now all of a sudden you have a tree of concurrent executions. All of them need to complete, but any of them might fail at any moment. All of them must accumulate state, and this is a distributed system. The core agentic tension remains the same: autonomy versus alignment. But now we add concurrency and distribution, partial order and partial failure to the picture. Now at first glance, this still looks like a simple agent loop. Right? In each iteration, we call the model, we append the response, we execute any tool calls, we append the result, and we repeat until there are no more tool calls. But in a concurrent, distributed environment, simple code runs into complex problems, and every line becomes a challenge. First, the agent instance is stateful. The agent state lives in a message array. If this process crashes, everything in the message, and therefore the entire agent instance, is gone. It forgets everything it did up to this point. Next, the agent instance is long running, potentially taking many terms before producing a response. The agent instance is also costly. Every call to the language model has a price tag. In a distributed systems, failures are normal. Processes crash, networks time out. But if our only recovery strategy is restart and take it from the top, then one failure can force us to rerun the entire agent graph from the failure point. Next, there is fan out, fan in. The first for loop spawns concurrent executions. Each tool call runs in parallel. In the second for loop, we await all of the results, while children complete in arbitrary order. If any execution fails, what happens? If the parent crashes between spawn and await, what happens to the children? If any child crashes, what happens to the parent? The agent loop is about 20 lines of code. that suggests we don't need an agent framework. But we do need to worry about durable state, reliable execution, coordination, and recovery. We need a distributed system framework. Now, distributed async await is Resonate's durable execution framework. With distributed async await, you can write your agent as a loop, and the framework will take care of concurrency and distribution, partial order and partial failure, and manage coordination and recovery for you. Now check out Resonate's implementation of the Deep Research Agent. It's a recursive distributed agentic application that can run for minutes or hours, even on a serverless platform like AWS Lambda, scaling to thousands of agents in less than 110 lines of code. Now, if you want to go deeper on durable execution or scalable and reliable agentic applications, don't hesitate to reach out, join our Discord, and say hello. If you want to go deeper on distributed systems, check out my book. If you want to say hello, reach out to me on any platform, like either on X, GitHub, or LinkedIn. And with that, thank you very much for listening.
Well, Dominic, thanks for that. We are still about 10 minutes behind schedule, so appreciate you getting us through this. Super, very interesting, and nice and abstract approach to the complexity of agent systems. To keep it going and also make up for a bit of the time, we're going to move to Kun Lin, a software engineer at TikTok. Good day. Let's get your slides up. So just to introduce, Kunlin will share a practical approach to making AI truly monorepo aware by building monorepo indexing layer and connecting it to the model through MCP and composable skills. So we'll look at what to index in a large monorepo, how to organize information at a package and workspace level, and how to expose these capabilities to tools. Let's wait for that to come up. It's been a bit. Okay. Good to go. And Kunlin, you have about just over 20 minutes, right? 25 minutes.
Right. Hello, everyone. I'm Lincoln. currently based in Singapore and working at TikTok. My current focus is on building AI applications designed to help developers write code more efficiently. One of the biggest challenges we face is enabling AI to truly understand the code base, especially for the monorepo that houses dozens or even hundreds of the projects. This skill presents a significant hurdle for AI agent contextual awareness. I'm excited to share my insights and hands-on experience in tackling these challenges today. And I hope it sparks some fresh ideas for all of you. Typically, we equip the agents with a set of tools to retrieve code. For instance, Cloud Code implements tools like read, grab, glob, and ls. It also integrates LSP, which stands for Language Server Protocol. By defining a standard JSON RPC-based communication protocol, it allows any new programming language to compatible with any to integrate with any compatible client by simply implementing a language server. LSP allows LSP provides agents with LSP provides agents with Okay, thank you. LSP provides the agents with real-time code awareness and diagnostic capabilities. It allows agents to see the real-time immediate error feedback after each edit. Go to the definitions and find out references, giving the agent a developer eye view of the giving the agent a developer eye view of the entire code base. This may suffice for small to mid-sized repositories. However, for massive monorepo, it still needs semantic code indexing. Without it, agents may struggle to map user requirements to the relevant source code they need to retrieve. Let's take to have a real-world example. Suppose we tell the AI agent, please shrink the height and width of the user avatar by 2px. Without semantic code indexing, agents may instinctively search for the user component or maybe the components with other request name. Even if it finds the components with client name, the agent it may include multiple candidates, as most of them could be relevant noise. So there is no way to pinpoint the target code based solely on natural language. Massive monorepo adds another layer of the complexity. Without proper indexing, agents is like someone searching for a specific book in a pitch black library, relying only on a flashlight to scan the random corner. On the other hand, we can leverage parallel execution and context resolution of multi-agent system to perform agentic search. A sub-agent executes the research and return only the final result. By executing the multiple agents, the main agent's context remains lean, containing only the result of the sub-agent's execution. Which maximize the efficiency of the context window. Typically, before agent generates code, it needs to install the dependencies. Once the code is written, it needs to run the commands like lint, test, and build to verify the correctness before submit. However, for massive monorepo, running this task across the entire code base is incredibly time-consuming. A fundamental capability for the any monorepo tool is orchestrating the task execution. For massive monorepo, but for AI agent, they often take a brute force approach, executing the commands within the entire code base. So it's crucial to guide the agent towards a sophisticated use of the monorepo tool and adoption of engineering best practice. For instance, when modifying package B, we need to install all its dependent and dependencies, and then run tests for all its affected packages, including the indirect consumer of B to ensure the correctness of the changes. Therefore, we implemented MCP and rules to address this issue. MCP is a unified protocol for tool integrations. It allows any different agents to invoke the tools in a consistent way. Rules, on the other hand, summarize the user or team's standard into a reusable standard system level instructions that can take effects in every sections. This ensures the agent's output remains controllable. By leveraging these technologies, we implemented Rush MCP server to give the agents necessary context and knowledge. And we also established Rush best practice rules for agent and adapted them for our mainstream agent. By combining MCP with rules, we can effectively constrain the agents only execute commands within the specific packages. This significantly reduce the agent's execution latency and boost overall efficiency. However, this introduces a new challenge as we pack our best practice into rules, which are typically loaded into the system prompt. This consumes a lot of context window, scatters agents' attention, and leading to the issues of instruction following. This is where the agent skills recently popularized, a concept recently popularized by the Anthropic, has become a game changer. It's leveraged progressive disclosure to allow the agent to fetch and load skills into context only on demand. Therefore, we implemented Rush stack skills to progressively disclosure best practice to agent. In traditional Euro, we adopted monorepo to enhance code visibility, facilitate code sharing, and maintain the standardization. However, in the AI Euro, everything has shifted. A recent article from OpenAI, Harness Engineering, leveraging codecs in an agent-first world, has revealed that agent throughput has far exceeded that of human. So in this context, code review will handle entirely by the AI agent. Therefore, the traditional method intended to boost human productivity are gradually losing their value. In the AI era, cloud agent seems to be the definitive answer, which means we don't need to manually set up the environment and allowing agents to run persistently and at scale. In the AI era, a monorepo is a collection of repositories maintained by a single team. All these repositories adhere unified agents configuration, like rules, MCP, agents RMD, skills, and more. These repositories are put into cloud simultaneously at runtime. Allowing us to better leverage agents team, where each agent is dedicated to a single repository, working in parallel and communicating with each other, working in parallel to modify these repositories simultaneously. By leveraging this harness for AI agent, we can unleash their productivity. This liberates us from the drudgery of the manually writing requirements, allowing us to focus on what truly matters: architecture and innovation. We are moving beyond the linear growth, stepping into the AI era of exponential productivity. Yeah. That's all for today's talk. If you have any questions, please feel free to reach out to me via this email. Thank you.
Okay, awesome, Kunlin, and I guess also credit to TikTok for open sourcing this, making that available to the wider community. If Anuchit, in the room, great. Let's have you present. Okay. So Anuchit is a principal technology consultant at Arise by Infinitas. He'll be taking us through a real example of how test-first AI workflows reduce hallucination, increase code quality, improve traceability, and align AI outputs with engineering standards. So over to you.
Thank you so much. Hi, everyone. Anyone here is not developer? Okay. What's your role, sir? Product manager. That's good for you because you need to have your team doing this. So every system that most of me doing is in an enterprise. So it's big and fragile. And that's what I'm dealing with every single day. But surprisingly, people keep producing the legacy code more often, even in use of AI. What I mean by that, people produce the code that no test at all, right? When we prompt things, the AI to generate code, is that produce test for you? No, it need to tell them to produce code, produce test. But however, producing test after producing code, You know the difference, right? So the code, it look different. It's harder for testing. So that's what QA don't like. And sometimes the context window is not enough for our big project. How can we work on that one? So hard. So easy. We need to buy more token credit. No, that's joking. So that's how the real situation that we do. And as a product manager, for example, have you wondered why we have an AI, but we still deliver relay at the same? So people not writing tests even in the AI age. Why we doing that? Why we still producing code without tests and we produce it more faster than before? That means it's hard to change than before. So as long as AI cannot writing entire code or change entire requirement without any bugs, that we need to write tests. Unfortunately, someone still believe that, oh, we don't need to write tests anymore. Someone still thinking that, oh, they just prompt and generate the application and ship it right away. They're still thinking that they don't need to verify it in the age of AI. That's surprising me a lot. But no, writing tests is so tedious and it's a lot of work. Just one function, you have like a 10 of cases, right? So that's a lot. But how can we solve the quality problem before the age of AI? Oh, we do that already with TDD, right? We write the TDD code. For some of you that might familiar, but most of you may familiar with this already. We writing tests first, and then we writing the minimum code that satisfy that test to make it pass. Minimum, not over engineer, right? Just minimum to make that test pass. That's how it is. But nowadays, AI generate all the things for you, right? Even the code that you don't need it. It just be there. But we need to scope the behavior that one, give us and more control for that one. So I introducing you a TDG. Not the fancy things, it's just the AI agent skill. But the idea is we take our practice for ourselves and put it out and take it to AI and let AI behave like what we want, which is produce the high quality code with the test. Why is good? Because when you have tests, you have ability to change safely. That's what it is, right? And TDG is helping us. Another step is it convert the requirement to be a spec and then writing code. Is that more better? It is, right? That's how the LLM work, how this thing work. Okay, let's demo. This is a bad idea. Demo this slide. So I at first, right? What? Have some point. That matter. The matter is after. So basically after what they what act on the so hey can put one file and I hey okay, try to run some script. This scripting is different from other skill. We have script that we have hash on it, and it will check the hash first before it run that script. That script used for detect that which state of the TDD that we are on right now. And then we just say yes to anything, right? When it's pop up. So, and then it will say, hey, this is the thing, blah, 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 and thing I going to do. And then it will try to determine the issue and the test coverage for us. You can see right now it's 0% coverage, right? So that's what we expect. And it will say, hey, okay, this is what I'm gonna do. It's based on requirement. We just say, oh, sorry, I need to say no for that. Oh no. Yeah, not a good idea to live demo, but it's okay. So, very good. And it will create folder structure, blah, 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 blah. But the thing that I want you to see is the behavior of it. It's here. It's writing test first. You see that one? And the test is writing is kind of same practice that we are used in the TDD. It have a AAA pattern, arrange, assertion, thing like that. You can see the test is pretty much simple. Yeah, that's one. Pretty much simple. And then it implement the code, follow that test, right? And the code, I would say that's how I gonna done it in my way. Sure. So this is the pretty decent code, right? But the good thing about it, I can change this one with confidence because I have spec on it. This one, I have spec on it. And if not enough test case, what I do? I just add another test, right? And mostly test case, it give us the requirement spec. That's good. So, and it continue doing that. You can see it one by one, do function by function. We have more granular control here. And every step is more better than we use alone. It's commit for you. This is commit each step for you. What that means, you can go back, right? You can rewrite, you can do anything with it. Because each step, it's like a time machine that we can go back. But if you are using the code agent alone, it give you this ability? No, right? Sometimes, code, this one is look good for me, and then I forgot to commit, and then you add another prompt, and then it blow you up. Boom. That is disaster. Anyway, it will continue doing this. So, the thing is, this TDG also have the atomic commit. Basically, it just helps you create a chunk of change and then commit it based on the context of those change. Automatic. So you just say this one, TDG atomic commit. Hit enter and it will show you, we have 3 chunks of commit and here is the commit, blah, 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 blah. So that's what the commit message is also good because of AI. Because of AI give us the context. The commit message of the atomic commit, it will commit all the things and explain all the things based on best practice of GitHub, right? Okay, that's what I want to show you. But however, if you apply this one to all the developer machine, you will get the code that have test automatically. Just let them use it, right? And you have ability to change it. Anyway, this is not my idea. This is my professor idea. Chanvit Kyagasi. Yeah. He is the legendary. So you can check out his GitHub here. Yeah. So anyway, in the age of AI, we need to make sure that we build the software that survives change. Because we people talk a lot about building software fast and new, fresh. But in reality is we need to build the software that lasts and tolerant for the change. Thank you, everyone.
Excellent, insightful talk, and lucky that demo worked out. Great. Anjit. We've got our next speaker come up, Deepak Kaul. And let's get you set up. No? It's in the browser. How do we exit this? Any idea? No? Ah, here. There we go. Okay, in that folder. No, let's go back here. This one? Yeah, go that tab. And let's go here. Click on. Yeah, you can do like that. Okay, while we're getting that presentation up, let everybody settle. Please do take a seat in the front, if you can. Makes the speaker feel more welcome. And so I'm going to introduce Deepak Kaul, a senior manager, software engineering department of Red Hat. Deepak is an experienced engineer with a passion for psychology, software quality, and now engineering. And so he'll take us through his experiences of testing, perhaps a bit in contrast to the previous session on test-driven design. And so let's hear about his views and what he's taken away from applying AI to testing. So, you all up and running? Deepak? Yeah, you're good? Okay.
All right. Hello, everyone. Thank you for coming. My name is Deepak. I'm an engineering manager in Red Hat. I came all the way from India. So this talk is a very natural sequel to Anuchito's talk that you heard just now. So what we are going to talk about is test generation using the AI code generators that we have nowadays. Okay, so around 1 year ago, myself and my team, we started using Claude and Cursor for testing. And then we'll use Jira MCP to get the ticket details, the change details. And then we knew that the Claude and Cursor both had the context of the code. They'll get the requirements from Jira. They'll also get some other context from Markdown files. And we'll be good to go with generating tests and then converting those tests into automated checks. So as Anuchito said, it's very easy. You could generate a lot of tests with in a minimal time, and everything looked like good productivity. And I can see how a lot of people are trying to get on this train right now. Is any one of you trying to get on this train using code generators to generate tests? Right. So if you are like me, I would like to, or I would rather volunteer to stand in front of that train with a red flag. And I'll tell you why. Now the thing is, why do people do this? Why do people use code generators to generate tests? One is everybody else is doing it, right? Why not? We have to learn how AI works in the quality domain. The second is whether we believe it or not, testing in a phased way has always been considered a bottleneck in the delivery pipeline. The feature becomes available very easily, but testing takes a lot of time. So to get rid of that bad reputation, people thought that, oh, why not increase the velocity and productivity? But this is where the problem is. Generative throughput that you generate through code generators is not actually your risk reduction. If you look at all the famous bugs, famous and costly bugs, you'll notice that they have always, in terms of probability, they have always lived near the long tail of probability. They are not the mean and median of the outcome. So let me tell you a lunch story. So let's say I have a team of 15. I ask them to go for lunch, and then I ask for options to my team. So if the natural option most of the time is we'll go get a pizza. But if I ask, let's say, only 3 people out of 15, possibly they might say, let's go and get biryani. But when, let's say, 90% of the people have voted and I choose for an option, that would mean that we can also go for sushi and all. What I'm trying to tell you is when you generate tests with the modern AI code generators, regardless of what your decoding parameters are, you're still getting a variation of the trained data, not an emergent behavior, not something it's not trained on. So it's systematically a pizza with different toppings, but still a pizza. You're not getting any other food. With top K with top parameters, what you're getting is you go to a restaurant, you say that I'll have what everyone else is having. But you don't notice that their chef has probably created a great Indo-Thai fusion dish that you should try, because that's not the statistical mean. And this is, and have you ever noticed that why do modern code generators lock these parameters for you? Because they are supposed to generate language and code. So if you generate a React component today, and after 1 week, they see the same React component if you give the same prompt again. They are not going to vary. Different language, but it's not good for an application. The simple example is ChatGPT and Claude once too, that is never heard. An unheard joke. I wanted to know whether it can create novel things. So it told me a joke that I went to a bar, something like that, and then no, I'm in a band, and I have done 1023. My band is called 1023 megabytes because I have not done a gig yet, something like that. So I asked it, is it a new joke? Is it based on something? It said, yes, I got it from Reddit, it was a programmer joke earlier. So I repackaged it for you as a dad joke. So the idea is going to get anything new, like poetry, screenplay, something new or emergent from coding tools or AI in general. And I'll tell you why. So there are two concepts of probability theory. One is epistemic, the other one is aleatoric. So epistemic is lack of knowledge. You don't know a thing yet. So training data is lack of knowledge, right? So hidden workflows, emergent behavior. Let's say you decide that you are going to deal with a third-party API, and now your code generator does not know how the system would integrate with it, what would be the bottlenecks and stuff like that. And unknown interactions that may come in the future. Those are lack of knowledge things. The good thing about AI tools is it's very good in aleatoric uncertainty. It generates variation. So think about a login page. If I ask both AI and a person to test a login page, the AI would generate thousands of username and password variations. It would use multi-byte characters, kanji characters, emojis even. But if I ask a person, they'll probably get tired after 10 or possibly 20 combinations and say that, yeah, it's working fine. So that is not a human strength, generating variations. Human strength is talking to people, having those mental shortcuts of having worked in such login pages before and coming up with something interesting and something which would be non-mean, non-median, and on the statistical tail of the distribution. So what we are doing actually is we are using a tool which solves the aleatory problem for doing what is epistemic in nature, which is exploration. So from a complexity theory perspective, exploratory testing is complex domain because there are some things which we don't know yet, like the unknown, right? Incident testing, like something broke on production, that is chaotic domain. Regression testing somehow is clear domain. And same with the analytical testing. You have a lot of data, you analyze what the equivalence partitioned input should be, and then you write your tests. The left side part is where humans do good. The right part is where AI does really great. So what should be the balanced approach now? So I generated this sandwich model. So we are still on the food, pizza, sushi, now sandwich. So human AI human model. That's all. I haven't given it a good name. So the role of the human is to probe, talk to the other people. So see, the whole idea is we kind of safely assume that even though the LLM is trained on some data from GitHub and Stack Overflow, but if we provide it enough context, it will give us the right answer. We overinflate our ability to document things. If something is in your mind or your friend's mind, how is an LLM going to gather that, right? The second problem is we kind of feel that we know everything about the problem, about the software in the beginning. Do you know who had such thinking around 40 years ago? The waterfall people. They thought that we knew everything about the project in the beginning and we can probably start. So in a way, we are kind of regressing towards the waterfall model. Okay, in human AI human, what do we do? The human does hypothesis formation, risk framing, and assumption probing by talking to people, getting decisions made. Like there can be open-ended questions, right? Getting those decisions made and probably documenting them if you want AI to generate tests based on those newfound information. What do you want your AI to do? Draft tests, generate permutations and combinations. The variation part, as I said, it is a aleatory tool, not an epistemic tool. Build this scaffolding around your tests and test suite. And then once that is done, because we still want to remain in the iterative model, right? We go again and check the AI output. We see whether there are any gaps. There is something more that the human should explore or get answers to aid AI in going from the round 2 and getting more tests or removing some of the tests. Because eventually every test is also liability, right? It has to run. And you have to check the results also. And you also the human also does the gap detection. Is there a part of the software like an integration or something that we are missing? Then you tell the AI to build tests around that as well. Okay, and with that, I'm open to questions. We still have 1 minute.
Okay.
Great. We're a bit ahead of schedule, but that's open for Q&A, either on AI, testing, or food. Any questions from the audience? Okay. Okay. Well, we can close it out with that. So, round of applause. Thank you. And we're heading into the 10:40 tea break. So we're going to resume here in a short while. Let me just give you the timings. So the AI track continues at 11 a.m. Thank you.
test.
All right. We'll see if anybody else, a few come back in after the tea break, and we're going to get started. Do come join us. Hope you all had a bit of a refresher, and we're going to do this A track this morning with Ramya Athapan. Is that right? Senior Quality Engineer at Circle Inc. This will be the presentation on autonomous playwright tuition, and we're also streaming this online. So you're over from India. Yes. Welcome. And why don't you take it from here?
Good morning, everyone. So, Ramya, I'm from Chennai, and I work with this company called, it's actually a community building platform. Yeah, you can check it. The website is circle.so. Look at it. Yeah, so this is very close to my heart because this is something that I really love building, and this is something that is actually, we use it at work well every day. So let's get started. So what is the problem statement? So basically, we do have end-to-end tests. Yeah, it could be from different test suites. For us, the tech stack is we are a Ruby on Rails shop, and we have Playwright tests to do the end-to-end test. So yeah, tests break for multiple reasons. Maybe there are some could break it, or there could be flakiness. That's a constant thing that the team writing again as well. So how do we? Whenever such things happen, we do look to the stack trace and the logs and try to debug and find out what actually went on and try to fix it. So this talk is all about AI and AI agents to automate this entire workflow. So the talk about, yeah. So as I mentioned, like when a test fails AI, the developer or investigate the logs and they try to replicate the, and also we try to debug and find the root cause and fix it. And but with this, what actually happens is all of this actually narrows down to just typing a single slash command. So, which is, I mean, this is what I call the command as slash fix playwright test for the fail. So it's like you not leave the you just type in this command and it works. So we'll go through it now. And also, yeah, a lot of things that were taken into consideration as well in terms of the kind of guardrails that you. So I'll talk about that. Alright, so this is actually the healing pipeline. So so whenever there's a failed test in a PR or in a private branch, you just type in the command called fix playwright test, okay, and followed by the test that's failing. So what this would actually do is we have a GitHub action which works on this trigger and would actually get the failing test and it would pass it on to the next. It would actually invoke a script, and that script is the one that is the core that has the core functionality of this entire thing, and it actually has we we basically use Claude Agent SDK to do the debugging and come up with the fix. And in our case, like we use build as our CI for our CI pipeline, so that's why build guide pipeline there. And it invokes Claude Agent SDK, which does the debugging, and it suggests the fix, which is again committed to the PR, and it's not directly pushed to, it's since we are actually working in the, so it's available for the developer to see like whether this change is acceptable, and then you can just go ahead with the, how it happens. Yeah, so as I mentioned, this is how it works. Like, I think we heard this, right? Like, the GitHub action, it takes care of a bunch of validations, and it triggers the build pipeline. So that's where this whole functionality happens. And all of these actions, there are the developer or the users actually get informed about the various things that are happening. Meaning, like, when the pipeline is triggered, then add a PR comment and set that. All right. So coming to the main, the crux of what it's all about. These are the two different MCP servers that we use, and this is invoke script. Like from GitHub actions, we actually invoke which calls these. Since it's a JavaScript a file that we have, which invokes, we make use of these two, and make use the Claude agent, which in turn calls these servers. And as you see, like this is playwright test MCP server. So there are two different things. Like playwright MCP is different, playwright test MCP different, and in playwright test MCP, these tools export like test run, test debug, and test list. So it actually would run the test even headless mode, and it would figure out like all what could get context, see like where it actually is failed for that, and then it goes into the debug where it would try to analyze and figure out where it's failing and try to fix it. And the Chrome is mainly for browser capabilities, need that as well. Yeah, so whatever we do as we try to debug a failure, those things are actually given to like a prompt file with guidelines that it needs to follow, that it can actually work as well we expect it to. So basically, it has the code context, and playwright test MCP has the context of the failure as well, and and also the debug information. And from that, the agent would actually apply a fix from test. And that also it's a minimal fix in the sense it could suggest a lot of things, but these are the things that we need to keep in mind when we implement. Not be suggesting more things, or I mean, those are not needed, right? Like, as long as keep it minimal, and as long as it fixes the issue, that so it keeps doing it till it finds a fix, and of course, once applies the fix, it's also verified. The playwright test MCP verifies the test that is applied and make sure the test passes. And about the safety metrics, there are a few things that we wanted to keep in mind, because when we talk about self-healing workflows, right, like the self-healing test, a couple of things comes to me, like, okay, test is failing, and how do you know it is a legit failure, or how do you know that where to fix it, right, the test, right? Is it the test that is broken because of change, or is it a real bug that is causing the test to fail? So that's the tricky part. So that's why we actually have a guardrail wherein like we allow the agent to modify only the test files and not the application code at all. That way we can believe that it's only the test that is being modified, because we have initially when we started exploring this, that was a tricky thing, because it was trying to fix the application code to make the test pass, but that's not going to always work. Right? So those are like things that we need to be real about. But then what happens if there is a bug? How does it handle? It actually says that there's no problem with the test, it's good, so maybe it needs human intervention, go and check your app. So that's how we have, that way we wouldn't be having, I mean, it's safer to do this than to actually go. No timeout band-aids allowed, meaning like, this is one thing that got suggested, like for test to pass, especially if it's flaky, the MCP, it usually suggests that we add timeouts and using timeouts. So that's like it's kind of a band-aid, right? It's not addressing the real issue. So make sure that doesn't happen. No unnecessary. Given the context, it could suggest, like, say for instance, it's into a test file. There are other changes which are like really good changes, but to test, to make this, to fix this failure, those are not needed, right? So those things are all, don't encourage that. That the context is, yeah. And stack trace guided changes only. So whatever, the debugging always happens based on stack that's there. And non-root user execution in CI. So yeah, when we add a Claude agent SDK in our CI environment, that's something that we need to be really careful about, because like, yeah, one thing is it's always better to have it as non-root and to give it the privileges, only those privileges that are needed for it to, so that and we also have a cap in terms of the iterations that it could go up to, meaning like it keeps it keeps debugging, right? With the Claude agent, if you've seen the conversations, it would actually say interaction 1, interaction 2, and basically it's on reasoning out that as it keeps doing the number of iterations. But we don't want to go it forever and ever. We also need to be mindful of the tokens that are spent as well. So thought it to have a cap, and if it reaches the cap, then we make sure that we stop it there, and if it doesn't fix by that time, then we actually call for human. Yeah, so another thing that we added here is mainly was based on the stack trace of the test failure, but there are other things that you can pass as well. You can actually categorize where, the reason for the failure. Is it a front-end issue where a selector mismatch and maybe the text tables, it could be that, or it could be a backend issue or a bug. And for that, usually what do? Like, we look into the logs, like maybe test.log, and we figure out like if there are like 500s and 400s there, HTTP errors, then we work on those lines. So we also have that built in, where like we get the test.log context, and there are errors, specific errors, like based on that, then we have different paths and different ways in which it debugs. And yeah, apart from that, could test environment issues as well. Maybe the ones that are using are outdated and the test data not good enough. So those things are also. So basically, what I mean, this is one of the steps that happens, wherein it would actually take different paths based on the classification of the failure itself. So since we have the agent SDK in CI, that like actually makes your CI system intelligent when you add Claude agent, not necessarily Claude agent, but the AI agent into your CI system, you're making it intelligent. And if you have the correct guardrail, you can keep expanding it. Like this is one such example wherein we have self-healing test workflows. And this in itself could be another use case. There is a build failure. You can have the build failure classified, and it could just add, maybe send a Slack message or add a comment in the PR so that it's easier for you or the developer to take it forward. So these are ways in which you could put. Yeah, I think touched upon this already. So what server will side. So we so it talks about how invoke the Claude agent, and and for every failed test, the agent is invoked and is actually auto-committed in the PR, and we do it only for private branches. And so when there is a code diff, know what is actually the change that is committed by this self-healing workflow is actually visible. And then we can give it it can be more automated sense, like whenever we see a failure in the pipeline, automatically trigger. We need not even have slash command. We can automatically trigger this workflow, but we wanted some level of control so that, we know what action we are invoking and can also control the output as. Yeah, and the same thing works locally as well. So the script that is given there, right? Like this TypeScript file is what gets invoked when this run playwright the type file, which has all of calls the Claude agent SDK, and which in turn calls the so it could be invoked. It could be directly invoked locally. The same. It's like an equivalent of what happens in CI. Right? So I think one of the biggest impact of this, yeah, mainly the developer experience, right? It's easier for them to know what is actually failing, and even they need not spend time fixing the test. Once they invoke the workflow, it's already there for them to look at the code change and to either accept it or they can remove it. So, key takeaways, like, yeah, MCP, like making use of it along with the AI agent, like the Claude agent is case specific. And yeah, it's designed to both in CI and local. So yeah, these are few takeaways that I saw. And one of the biggest thing that I saw personally out of this whole work, right? Like the biggest thing for me is, yeah, of course we implemented self-test workflows, but it's more than that. I was more fascinated about making the CI system intelligent because it has actually opened a plethora of options. Actually, it's just your imagination that's a bit with right guardrails. You can just build really good tools. For example, another thing that's currently being it's implemented and it's experimental at selective test execution, wherein based on the like the Git diff, you figure out the list of tests that needs to be run, and that would be that's proving to be really useful, not just in terms of faster faster feedback time, but also in terms of making the best use of the resource, right? Like you're going to run 500 tests for every Git commit, we can actually narrow it down to 5 or 50 or 150 tests maybe are like really needed for Git commit. Yeah, you can just keep, extend this what want. Yep. Questions?
Got time for a question or two.
Yeah, like when having a test failure, how do you differentiate, or when you analyze it with the LLM, how do you differentiate between a possible failure in business logic versus, for example, a text in the text field, which may have due to some other causes?
Correct. So that was first problem that we faced when we implemented this. That's like, so a test failed. Where is the problem? Is it a problem with the application code or logic, or is it a problem with the test itself? Should the test be fixed? So we opted to always fix the test alone, not fix. Just ensure that the whole workflow or the script it can only, and even then it's if it's still failing, then we call for human intervention. When it says like I see an error and also see these JavaScript errors, and there's nothing wrong with the test, so maybe there's a problem with your application code. Might happen. That's how.
Okay, thank you.
Okay. I think we're good for the next session. So Ramya, thank you so much. Appreciate you being here. Okay. About AI in the pipeline, certainly making it easier for developers to ship code. Going deeper into this topic, we're going to have Goa Handyon present. He's the Chatham from OpenEULA and a long-standing Linux kernel upstream maintainer, so taking us right into the heart of the platform. And Goa will take us in the session through OpenEULA's AI exploration and the SuperPod Oz initiative. and highlighting how the operating system stack is being optimized for heterogeneous compute high-density AI clusters. Thank you.
Thank you. Hi, morning. So I'm Hanjun from Open User Community. So today I share some a little bit low-level software regarding to introduce what we did. Yeah. So the first one is the intelligent application platform. So things I'm a operating system guy. I'm working on the Linux kernel for years. So and also work on the ARM server for years. It's the biggest thing is that how to make the ARM server the performance is better, right? So here is we have the intelligent planning. So we got a multi data we in the history to how to turn the operating system the performance and how to make hardware the performance run better. And on top of that, we we have a give the data to the model. We have a specific performance planning model, and trying to compare if an expert already perform is turn the performance of the application, and we run this one. On top of that, we also can get some performance gain. Yeah. So before that, we trying to get the performance, into a good state. It takes people for day, but with this, we can just about 1 hour. Yeah. So this is the first thing we did. Is for the performance. And the second one is for the operation and the management. Yeah. So we have a AI-powered observation for the real-time and the convenient for analyze. So the first use cases for this one, we are using that for the AI training system. So the pain issue is that if one card in the training system is in a slow state or is a dragging state, right? So we are poor on all the performance of the AI training system. So how to get this one to be discovered? So we have a multi-layer of the profile, including the GPU and the CPU, and also on the kernel level, and the stack, and the head-top stack. We got all the information, and we have a history is AI-powered intelligence. So we get the analyzed results and to 95% in the scorecard identification. Yeah. So this is for the operation and the management. Okay, and let's go down a little bit. Yeah, this is for the runtime acceleration. So we work together with Beihang University. So this example key. So for now, we run the module and on the GPU, NPU only, right? So we're trying to do, okay, the CPU side is, is low, is really run a little bit. Why not transport a little bit from the GPU to the CPU, right? So since there is for the MOE architecture, there is a party of the expert. So if the expert, is not in the hot state, how about transport that export to the CPU side, and we can make full use of the system, yeah. Then to get the boost for the performance. So we already did that. It's open source, and so we got some performance boost, but there is also some something we need to address, because when the export from the NPU to the CPU side, there is some performance data, and I think this is more used for the with the GPU or NPU is not that strong, yeah, and then we can, especially for some laptop or something like that, yeah, that's for the export. Hey. And yeah.
Test, test, 1, 2, 3.
I grew up in the US. I've been living in Cambodia. I'm visiting Thailand. Today's schedule is looking a little more tight than yesterday, so fortunately, we have less time for questions. All right. So first up, I'd like you all to please welcome Bang, the CEO of Guardian AI and a serial entrepreneur with more than 20 years of experience in enterprise technology. Bang is going to talk for 15 minutes about open source AI agents, architecture, patterns, tooling, and governance.
Okay, thank you. So thank you everyone for joining my session. A bit of the self-recommendation. I'm Sathapon, or call me Bank. I'm from Guardian AI. We provide AI solution to corporate and enterprise. For example, we provide the chatbot, RAG, MCP, AI agent solution, also the skill tailoring for Claude and OpenAI, also provide the AI red teaming service as well. A bit about our solution, and we got a winner award from East Global in Tokyo, East Hackathon, and also the first runner-up in SCB Hackathon. Also, I am the advisor to National AI Strategy Committees and fellows in AI Governance Center, and also the committee in AI Entrepreneur Association in Thailand. And lastly, I'm honored to be the ambassador for AI Alliance. AI Alliance is the group of AI open source that join force to push the open source in AI. For example, Meta, IBM, Hugging Face, LangChain, LangGraph, and many open source players, also universities. And today we are gonna discuss about AI agent. So first, what is AI agent? Think about this. Before this, we have a lot of AI automation, AI that do things for you, but it will do things that you say it should do. For example, it can be rule-based, or it can be guided by the model. But AI agent is something beyond that. It has the autonomous, because it can think, it can perceive things, and it can make decision and do the action by itself. So that so it won't just do what you do, but they think before they do, and they will take action in their own name. In comparison, AI autonomous usually execute the predefined workflow, but agentic AI usually plan, think, and before they do, so it can dynamically plan what to do. Also, autonomous AI, it can optimize, but in the fixed boundary. But agentic AI, because it has autonomous, so it can choose the goal from your command, your order, what you tell them to do, or from the input. They can choose the goal by themselves and derive the sub goal by themselves. So the boundary is not fixed. The AI autonomous is rule-based, or sometimes it's prediction model-based. But agentic model usually on reasoning-based. So it's back to the model that can reasoning on what to do. For example, autonomous AI, you can think about a system that reorder your coffee or your tea, or maybe your detergent every week. Or something that when it sees that your supply stock is only have 1 week left, so it order order in for you to refill your stock. So that's the autonomous. But for agentic AI, it can think beyond that. It can, for example, if you have an inventory that usually in March, they will deplete, your inventory will run out in 2 weeks, and it takes 1 week for delivery and processing. So it can calculate that, okay, I will order it, we need 3 weeks in advance to reorder, but maybe in December, this amount of stock will be run out in 1 week, and we need 1 more week for order. but December usually busy, so we need maybe we need 2 weeks buffer for any kind of error that happens. So AI will think that, okay, we'll need to order this or 2.5 weeks before the order run out, for example. And before this, I cannot have this slide because earlier this year, there are a lot of ready-to-use AI agent and make the AI agent the hot topic in AI right now. For example, OpenClaw is the first one in the industry that provides ready to use. You can deploy it and tell it what to do in the MD file, and they will do what you do, automate everything, agent loop, memory, and everything that we'll discuss today. And since it is, and also it is open source, and since it is open source, so many development team can also rework itself in another version. So we have another claw, we have another claw in Rust, in Python, and in any kind of technologies. And in closed source system, we also have many tech provider also issue their own kind of agent. For example, Claude Cowork, and just this morning, Microsoft also launched the Copilot Cowork, the version that work with their Copilot ecosystem. So that's the idea how the AI agent look like today. And why we need open source? Why we need open source? Because first thing, as we talked before, it can think by themselves. It has autonomous. It can set their own goal and work toward that goal. So we need transparency. We need trust. How can we that what we think and what is the reasoning loop they use, the tools that they will use, and what kind of tasks that they will not go beyond. If the model is tricked to do something that it shouldn't do, what will they do? So that's a kind of transparency and trust that open source can provide to developer and also to user. Second, it's observability. Transparency and trust comes with the observability. How we can make sure that each step that AI agent take, each decision that it takes, it is the good way, and it will not harm other people or harm the system. Also, the customization. The ready-to-use closed source, it packed with everything. You cannot change anything. If you want to change, it can allow you to change a bit. For example, you can install tools, plugin, or change the system prompt in your system, but you cannot choose how do embedding, how do they do the vector search, or how to put the guardrail. But open source allow you to change anything. You can change foundation model, you can change vector store, database, memory layers, and also the agent loop. Also, low vendor login and community-driven improvement. Open source has been a living proof that community-driven development is the most trusted source for speed and also for the security. So that's why everyone here is here today. Okay, and if we go a bit deeper to the component of AI agent, what we will see. First, a typical AI agent look like this. From user, we need one agent orchestrator, because below that you might have multiple agent, multiple components that work underneath. So we need one agent orchestrator. And beside this, you will have one planner, or you can think it is the brain of the agent. It will plan the big tasks and break down into smaller tasks. And each smaller task will be handled by the reasoning. And the reasoning LLM will do the agent loop that call tools, think, memory, store, check the environment. And it will repeat on that loop until the agent thinks it is finished. So first, we'll discuss about planner. Planner is a heart and soul of the AI agent system. It breaks down the task, create a plan, what to do, what kind of action we need, and what is the end goal. This is very important because it runs all in the loop. What is the end goal should look like, and how can the agent know that we reach that end goal? For example, if a user want to build a market report for EV company, the planner will break down into smaller steps. And after that, for each step, the reasoning LLM will think in agent loop, like what to do for this step and what is the action. For example, for researching EV companies, they will do the web search for top EV companies in 2026 and observe the result. If that satisfy the action to the goal of the plan, and they will move on to the next. And in case you need multi-agent to work for you, so the planner will be break down and allocate the tasks to do smaller agent. A smaller agent will do the agent loop as well. Orchestrator will also control everything that beyond the planning. For example, what if they fail? What if they need replanning? What if the agent run in infinite loop? How to exit? That's the role of orchestrator. And this is as I mentioned, this is heart and soul of the AI agent. So we usually put the most advanced or the frontier model at this stage. The open source choice is abandoned right now. Last year I can gather only a few open source option, but right now we have Quen, we have GLM, Kimi, and Minimax, and many other models that can run on your own cloud or even can run locally. At the first week that OpenCloud launched, Mac Mini was ran out in many places, including Bangkok, because people run to Apple Store and buy it to run its own AI agent. And also on the tool side, for example, we need a tool because AI agent can think and do the action, so they need tools to do action. For example, API call, check the database, and do the computation, and work with file system as well. One component that very popular and also open source is Composio. It provides the ready-to-use tools to connect to like Gmail, GitHub, Slack, Jira, Stripe, and hundreds of tools. It's ready to use. Also, if you want to get the content from the website, the file crawl is one of the best tools that is open source as well. But if you want to do something inside the browser, not just getting the data, Playwright, it starts as a browser automation framework, but in AI agent, we use that to interact with the website, to input the web form, log into the website, extract data, upload file, and make the interactive session with the web browser. We use Playwright. And also other necessary tools, VectorDB, many very good open source option, Mervas, Quadrant, Wave8. Also in Python code execution, we have open source option, we have Jupyter and also E2B. And agent framework, luckily, most popular agent framework are open source. We have LangChain and LangGraph is one, the first one in the industry, and it may need a little learning curve, but it provides a lot of flexibilities. Google also provides its own AI agent framework development as well. It relied a lot on Google way of thinking and Google ecosystem, but it is very good, a very easy place to start if you want to work with something that they can provide, but it may not flexibilities. One reference example on OpenClaw, you can see that OpenClaw uses the same infrastructure, the same layer that we talked before, but they have a memory, but you cannot work, you cannot like sorting with that. It's only for themselves. If you want to have your own memory persistent or temporary, you have to work by themselves. And this is the reference architecture that AI agent today usually work with. And one more important thing is because it can do anything. It can, maybe you have read on the news, one solo developer mistakenly got their Terraform file deleted by AI agent, or AI agent mistakenly delete all the email. So we need, first we need the identity of authorization and identification system for agent to make sure that you work with the AI agent. Also human in the loop, and also the prompt injection and guardrail to make sure that it's safe.
I'm very sorry, but we are out of time for this session. Thank you so much.
Yep.
Next up, I would like you all to please welcome Deputy Man, right? Staff developer advocate at Confluent, specializing in modern data platforms and streaming technologies. Deputy Man's talk for 15 minutes. Graph AI agents about the plastic topic.
Thank you. Good afternoon. My name is Diptiman. I'm a principal developer advocate with Confluent. Second session after lunch. Hope you had a wholesome lunch. So I'll talk about how to build a data engineering AI agent today. That's my LinkedIn if you want to stay connected. And what I'm going to break down is the build, the QA, and the deployment steps of running an agent in production. How do you do it? So let's start with the problem in hand. Let's take a retail store. And let's say the data engineering AI agent that we are going to build would answer two questions. One is, as a business user, I would like to know which store IDs are performing well today, which is like the real-time information. And as a business user, I would also want to know which stores have been historically been giving the most sales, which is like historical data, some trends. So at a bare minimum, to have this agent in production, let's plan for 3 agents. One is a Kafka agent, so which would give me real-time information from Kafka topics. Let's also build a DuckDB agent, with which I would query a data lakehouse, where I have my iceberg tables with, which is getting populated from data from, let's say, SAPs and CRMs for Customer 360, et cetera, of the world. And then we'll have an orchestrator agent, which would combine these two responses, validate, and then send the end answer to the user. So how do you build it? So traditionally, we relied on SDLCs, right? Software development lifecycle, which is almost similar to testing it, developing it and testing, unit testing it locally, and then doing maybe some sort of an integration testing in stage. And then the QA team gets loaded, who would test in dev and stage, and then you deploy it in production. Unfortunately, that will not work if you are doing the same things for an agent. The agent development lifecycle doesn't follow that. But having said that, it is also not a whole lot different, but the couple of steps that actually differentiates is the choice of your model, the kind of fine-tuning you do with your model, and then of course the rest of the development. So if you look at this image, which I've taken from MLflow, which is an open source LLM ops platform, people who have worked with MLflow would know that it still is a very, very good platform for ML ops. So now they have come up with MLflow GenAI, which is very good for LLM ops as well. And you look at it, you take a look at the first step. So it talks about a vibe-coded application first, which gets sort of an early signal from your end users, things are working, things are not working, etc. And then comes the QA loop. So we'll go a little deeper into the QA loop, how it works, which actually MLflow will do it for us. And then of course the rest of the matter. You get a stakeholder sign off for production and then you deploy, and then you create a feedback loop so that the agent keeps on, right? So what are the steps for building? So it's actually a trinity if you look at it today. So you have a combination of agent skills, which is like a very broad configuration framework of how the rules, the context, and the knowledge would work together. You have MCPs for accessing data, and then you have the agent framework, which would coordinate and orchestrate the whole process. For this one, since we are building a Kafka agent and a DuckDB agent, I'm taking two open source MCP servers, one maintained by Confluent, the Kafka Flink and Iceberg, and the one maintained by MotherDuck, which is the main company behind DuckDB, which maintains this DuckDB MCP. So if you look at this sequence diagram, you would realize that the MCP invocation flow would remain the same for both Kafka as well as the DuckDB agent. So the AI agent would send you a prompt or a request. The MCP client would take that request and would introspect with a reflection call with your LLM by loading the list of tools from MCP, figuring out which tool to call. So for here, since we are trying to figure out which store is doing our best, so we do a tool call with some order information, and then what happens is the MCP server then talks to the Kafka cluster, which let's say this time is situated in Confluent Cloud. So it consumes these messages, reads these offsets, sends the formatted store ID list to the MCP client, and the MCP client again invokes the LLM and gives you back maybe a structured output or sensible human readable output to the user, right? And for DuckDB MCP, same flow. So instead of the Kafka MCP, we would have DuckDB, and instead of the Confluent Cloud Kafka cluster, we would have maybe a Databricks or your S3 table, maybe a big. So once we have the responses back from Kafka for real-time orders and from DuckDB MCP for historical order trends, the orchestrator agent takes it back and then sends it to the user. So that's the overall the requirement flow of build. For build, we take LangGraph, which is an agent framework, again open source, coming from the house of LangChain. The advantages are you can actually build pretty sophisticated graphs, which are cyclic as well as could be sequential. Many other frameworks are there in the market today, which are almost all of them are open source. AWS Strands, Crew AI, AutoGen, etc. But then this excels when you have a relatively complex graph and you want to fine tune the way the whole thing works. The framework itself has three main foundation layers. One is called a state, which passes the information from one node to the other. Each node is a physical unit of your workflow, the business workflow that you're trying to emulate, which you're trying to replace. And then you have edges, which connects these nodes and creates this graph, right? So for us, the state would be simple. I would only take the user question and I would pass the Kafka response or the DuckDB response. We would need to create these two agents, which are React agents. I mean, people who are working with LangChain would understand that create React agent has now been superseded in LangChain 1.0 with a create agent. Anyway, this is still backward compatible. So what essentially it does is it runs the MCP server on a specific port, on a streamable HTTP port, and then lists all the tools, and then invokes whatever user command is being passed to the agent. Similarly, for DuckDB, absolutely the same thing. It loads tools from the MCP server, creates a React agent, which reason and then act, and then takes the user command and runs. And this is where, if you're on the backside, you can look at the side screen. This is where the graph is being built. So I start the node and then I call the Kafka, which is on Confluent Cloud agent, the DuckDB agent, and then it all comes to an orchestrator, which I've called aggregator. it takes the user command, and then it invokes those agents, right, and keeps on running. So that's the build bit, right? So now let's come in and let's understand what the QA part would look like, right? So the QA would actually be again a trinity of tracing the requests, evaluating the scoring the request responses, and then evaluating the whole system, right? And this is where open source ML flow would come into play. Before we jump into QA, we might also need to fine tune the LLMs on the specific domains, which is, in this case, is a retail one. So we might want to fine tune our models a little bit, because we might use manual data sets, which might be generated by the LLM. We could also use evaluator LLM as judges. So a fine tuning again would help. So for tracing, all you need to do is you just replace the mlflow.provider.autolog, and every single call from your agent would be logged. So MLflow supports more than 45 plus frameworks today. So all you need to do is just replace that lang chain with whatever. If you're using strands, you just use strands. If you use QAI, just replace it with QAI. And what happens is every single call is traced. So this is the example. So if you can look at it, I'm first calling the agent calls an LLM model to load all the tools. And then you could also see the tool call happening on the bottom. And then it gives you the input and the output, as well as the token budget, which is the most important thing today. So whether you're actually wasting tokens away or not, so that we put some sort of a throttling at the input token and the output token expense. Once you have your traces, again, it becomes a loop of doing tracing, scoring, and then followed by a evaluation predict function. So for evaluation, you can see on the lower side of the screen, I have taken two matrices, correctness and relevance to query. There are more than 30 plus metrics today in MLflow. So you could have things like tool call efficiency, tool call effectiveness, correctness, completeness, even user frustration. Like if there are follow-up prompts in a multi-turn conversation which says, I'm just absolutely fed up with the shitty response that I'm getting, you can actually log it, and it would be treated as an user frustration metric, and you can measure it and score it and evaluate accordingly. Once you have that, let's say your QA loop is over, you think of deploying it. So for this example, for today, I've taken AWS Bedrock Agent Core as my deployment platform. And Agent Core is model agnostic, Agent Core is framework agnostic. So all you need to do is build your agents and then deploy it in an Elastic container, deploy it as a Docker container, register it in AWS Elastic Container Registry. It also gives you plug and play components like Agent Core Gateway, which tracks, audits, monitors, throttles, rate limits, calls to LLMs and APIs. It also gives you Agent Core Browser, which is like a browser automation tool if you want to call it within your from within your agent. It gives you Agent Core Code Interpreter, where you would be able to run Replit kind of Python shell. And of course, Agent Core Memory for creating a buffer in the multi-turn conversation that you might have, right? So essentially what happens is you build the agent framework, you build your agent with a specific framework, model of your choice, and then you create a Docker file with your Python app, and then you register it with Amazon ECR, which is the Elastic Container Registry. And then what happens is Agent Core Runtime provides you with a micro VM. So for every single agentic invocation, a new micro VM gets spawned till the communication lasts. And that micro VM endpoint to a user like me would just be a /chat or a /invoke or /consult with an agent. And I could just pass the prompt as a HTTPS post, and the agent keeps on running and giving me the cloud. So that's it. Thanks for listening. And I have 1 minute. If I can take one.
Anyone has questions?
There's obviously a lot of competing agentic frameworks emerging. I think I've played with one called Agno, for instance.
Agno, yeah, yes.
Do you see any of those taking the lead and setting more of the baseline, or do you think organizations will end up with, I don't know, 2 or 3 different frameworks in the implementations?
Yeah, so what I see is two very distinct paths that most of these enterprises are taking. Believe me, everybody is trying to deploy agents in production. If your enterprise is heavily invested in one particular cloud platform, let's say AWS, chances are there you would probably go with a combination of Strands plus Agent Core. If you're into GCP, chances are there it would be a mishmash of an ADK plus Vertex AI. If you're in Azure, it would be an overtly AI Foundry plus Azure OpenAI, which is deployed on Azure. But having said that, there are also companies which are trying to remain open source. So in those cases, you build it with LangChain deep agent. I mean, normal LangChain will not work. But then remember, LangChain deep agent is only sequential. It cannot branch off. So that's why you would need LangGraph. So if you build it with LangGraph and then evaluate with MLflow, you have a completely OSS stack. But then you have to still keep in mind that your inferences need to be fast. So you need to, I mean, I have not seen any deployment, to be honest, on premise. But then theoretically, it's absolutely possible. You can still get all these open source models. You can get a very costly NVIDIA machine and then ensure that your inferences are up to it. Otherwise, you won't get the right inference. Just not possible.
Thank you so much, Deputy Man. Next up, I would like you all to please welcome Sahan. He's a data scientist and ML Ops specialist working with Information System Associates in the Air Arabia group. Sahan is going to talk for 15 minutes about adopting open source tooling for fully automated AI ML Ops.
Hi guys, nice to see you all in FOSSASIA, and hope you are having a nice evening. So yeah, so today I was planning to talk about OpenMLOps, more or less about adopting open source tooling for fully automated MLOps platform creation. So before moving forward, how many of you are ML engineers? Data scientists? Okay, cool. So yeah, if you're seeing me for the first time, I'm Santi Sanayaka. I'm from Air Arabia Group, so I'm working as a data scientist. So I'm not new to open source. I was part of GSOC program, and also I'm a former Gold Microsoft Learn ambassador. If you want to stay connected with me, these are my social handles. So yeah, I want to discuss about 5 topics today, and I just want to pitch what's the problem about like creating a proper MLOps platform. And then what's about fully automated MLOps platform? And then what is CI, CD, and CM, and CT? And what is Open MLOps, and how to build a proper platform using Open MLOps architecture. So this session is more or less architectural exploration about Open MLOps and how we can properly utilize open source tooling for MLOps platform creation. So do you know 87% of AI and ML projects never make it to production? So it's hard to see. I mean, it's a sad news, but that's the truth. It's the main reason is data scientists want to reproduce research, but they don't have a tool to reproduce ML. At the same time, they want to rely on your own data, but they don't have a proper platform to keep and maintain their data. At the same time, they want to share the models and the results with fellow data scientists. So they need collaboration, and also they want to iterate on it, on top of it, like continuous serving, and also keep track of all the experiments like they are doing. So simply, they need a tool to do all those stuff. If we search for the tools, just go to the Google and search the man landscape, you will see plethora of tools that are available, readily available for you to use for all those stuff. But it's not only because of tools, it's because of the platform difference between the research and the stage and the production environment. Because when we are in POC and the ideation phase, we just have an idea to build a ML model. But when we move to the production environment, we need to do a lot of refinements, a couple of changes. So, and also when we extract the features, we are just taking a sample. But in stage and the production, we do real-time ingestions and we do bulk process. And also in stage, I mean in research, we do prototyping, but when it moves to production, it's scale. Like we do a lot of bulk processing and real-time and production-grade preparation at scale. At the same time, in terms of model, it's small scale, and when you move to production, it's event-based and scheduled. Same goes for the monitoring as well. So it inherits the high technical depth, scalability, cross-team function, and also automation. So it's not just about the tools and also the platform difference. So a couple of examples. Do you think we can run Jupyter notebooks in production? Not really, right? So because we need proper refactoring, modularization, and containerization, and also operationalization. Also, do you think we can process large data frames pandas? Not really, right? We need something like DAS or modding packages and the wrappers for us to do proper processing in production environment. And also, for the inference, hope you guys are well aware of BLAST, and it's not production friendly, so we need to move forward with fast API sort of framework for us to serve properly in like large scale enterprise environment. So it's just the first step, like the model development, it inherits a lot of technical steps. So we must have to pay it. So, and also it just takes few weeks to develop a model, but requires a lot more time to package, scale out, tune, and automate all of others. So how and why open source tooling comes to play and why it's crucial. So proprietary tools often fail on their promises and end up in high cost. And they often promise they have these features, but it comes with a price. But when it comes to open source tooling, it offers a lot of low cost and more flexibility when we onboard for a MLOps architecture. So now we can easily move to the fully automated MLOps platform. Before that, I just want to glimpse about what is MLOps. So MLOps is more or less like focusing on streamlining the process of taking the machine learning model to production while integrating the best practice. It's more like DevOps for the software development. But if we take into consideration with MLOps for the AI and ML projects production, you see, now we can clearly map the researcher's requirement and the tool, and also how we can use tool in these sort of tools. Like for an example, to reproduce the research, we can easily integrate Jupyter Hub. And also for the data, we can easily use a feature store. And for collaboration, we can use an experimental tracking tool like MLflow. As you heard for the previous session, MLflow is a great tool to do whatever the ML model registering and experimental tracking. Also for automated pipelines, we can easily utilize Airflow, Prefet, and Fast API. So what is CI/CD, CM, and CT? So it comes as a partial practice of MLOps. So it's about continuous integration, delivery, modeling, and the training. So a fully automated ML service should stand out as philosophically like this. We have a model, then we have a prediction pipeline, and then the monitoring service should track each and every serving of the model. Then it automatically triggers the training pipeline again when they want another model. Because while the time moves on, we have a lot of data drift, concept drift, so we need a new model for the new behavior. So that's why we have to keep this pipeline triggered again and again. So this is one of the famous frameworks by Google for fully automated MLOps architecture. So as you can see, we can clearly see how the tools are integrated with each other to utilize and to serve the purpose of continuous integration and the delivery with the training and the monitoring. So yeah, it's a cute theory, isn't it? But how to prove it with open source tools? So that's where Open MLOps comes to the play. So it's a great architecture introduced by Data Revenue. So kudos for those guys. You can easily go to GitHub of their repositories and check out their repository. So it's more or less ready to go MLOps architecture. So as you can clearly see on the left-hand side, you can see the data layer, and then the feature layer, and the modeling layer, and then the monitoring layer. So from top to bottom, you can clearly see the responsibility. So also on the right-hand side, you see how we can utilize each one of the responsibilities into the tool. So yeah, you can easily configure the OpenMLOps architecture as you want, because if you are not familiar with Prefed, you can easily like swap with Airflow. And also if you are more or less familiar with Fast API, you can trade off with Seldon. So each one of the tools has the serve of purpose in different responsibilities. Yep. So I will quickly show how you can build your own platform using OpenMLOps. So before that, you need a couple of installations like Git, Docker, and Terraform, Kubernetes. So just go to the repository and just fork it out. And then you just have to configure the infrastructure using Minikube, I would say, because if you're exporting by your own, just go ahead with Minikube. It's really easy. And set up your configurations and initialize the Terraform. And you're done. You are good to try out OpenMLOps. So this is just exploration, like you need a Docker or a VM environment. So you can easily set up it on your own machines, Linux or macOS, and also in Windows. So just a screenshot that I put after like successful installation of Minikube, and then just do the changes and configuration changes as per your own. Yep. Finally, I just want to mention, you might be a researcher, you might be a startup, in a startup, maybe you are a curious guy into MLOps and machine learning, and also you might work for a large enterprise also. So each one of the cases, this Open MLOps will serve the right purpose for you to implement your platform needs for machine learning. And that's it. Thanks a lot. I can take up a few more questions from you guys. Yeah. Any questions? Looks like no questions. And thanks a lot for listening.
Yeah, thank you. Thank you, Sahan. We will wait just a couple minutes to let others from other rooms come to this. Wait, is Mohammed here? Please come see me.
Okay, hello everyone. Good afternoon. So this talk was yesterday, but we had some minor technical issues. Did one of you attend the talk yesterday on the same topic? Okay, a couple of folks are here, but hopefully it will be something for the rest of the audience. This talk is named Abstracting the Data Plane. Why your AI strategy needs a feast data gateway. There's a lot in there, but in short, this talk is about something called as a feature store. A quick show of hand if you know what a feature store is. Anyone from the audience? Okay, so by the way, Feast, the logo that you see and Feast was also there in the previous slides from the previous speaker, okay? So rather than showing you an architecture diagram about what Feast is, where it fits into, maybe let's give you a very short example. If you're traveling for FOSSASIA, you are probably staying at a hotel. You are, eating at a restaurant, buying a bottle of water, or let's say buying a coffee. You're using your credit card to, buy that thing. So whenever you do that, a prediction request is triggered somewhere in a machine learning system with your financial service provider. The information that is there will be your credit card number, the amount, the purchase amount, and a merchant ID, okay? Just 3 pieces of information at the minimum. Is this enough to decide whether the transaction was fraudulent? The answer is no, right? Because to decide that, what it needs, your machine learning model needs a lot of context and a lot of history, okay? Where does it get that? It gets that from something called as a feature store, all right? What would be that context? The context will be like how many times the card was swiped in the last hour. What is your credit history with the bank? Let's say, are you at a very different location? Like in my case, I usually use the card in India, but this transaction is happening in Bangkok. So are you getting the idea? Like these are the kind of context information that I'm talking about. And this is where feature store comes into picture. Why should I be talking about feature stores? So hi everyone, my name is Gaurav. I work at Red Hat. I lead the feature store team at Red Hat. It's part of a product called as OpenShift AI. If you know Red Hat really works well with open source software. We have an upstream first policy. What it means is all the bug fixes, all the features are first added to the upstream projects before they are included in our offerings or our software. In the past, I have some experience working with the product security team at Red Hat, where I work on securing some of the offerings that Red Hat has, like RHEL and OpenShift. I occasionally speak at other conferences, and I do write from time to time. Here are some of the places where you can find some of my articles. With that, again, if you attended the last talk, this was mentioned in the last talk as well. So this is a very popular paper, slightly dated from 2015. What the paper argues is building machine learning systems is easy and fast, but running them at scale for a long time is really difficult, okay? The reason for that is if you look at the diagram, the machine learning part or the machine learning code is a very tiny bit of the entire life cycle. The problematic bits are the surrounding parts, which is about the data collection, the data plumbing, the monitoring, the infrastructure, and all of it. What they're trying to say is machine learning systems have a habit of acquiring technical depth much faster than traditional software, okay? Here's the link for the paper, which you can have a look at. So some quick background of why this is important, right? If you have seen the trend, which is happening in the last couple of years, is we and even the organizations are moving from being AI curious to being AI critical. So we are depending more on AI. So we are no longer asking if AI can do something for me. We're asking if AI can do it right, do it in the correct time. Is it ethical? Is it secure enough? Okay. So what this means is we are evolving beyond one-off models to a more structured way. We're trying to manage the complexity of this. And for this purpose, we need to create foundations that will accelerate innovation for us. Let's look at the current challenges, okay? So you see some points mentioned there, but let me give you a small example. All of us are attending FOSSASIA. Let's assume FOSSASIA comes up with some mystery swag for some of the people attending the conference. But to decide that, it needs to give you a score. Let's say the parameters for the score will be, let's say, did the person come at 9 o'clock, okay? Did the person attend at least 3 sessions a day? Did the person raise a pull request on GitHub for the FOSSASIA projects, right? So based on these parameters, let's say a score is created, which will be like an engagement score. And based on that, the swags will be handed out. So let's suppose there is a t-shirt booth. So how would a person at the t-shirt booth calculate the score, right? Maybe they'll scan your badge as a start. They will look up some Excel sheet somewhere. They'll try to identify which are the talks you've attended. They will probably go look up your GitHubs to see, and they'll come up with a score for you, right? You see all this work that they have done, and the score is calculated. Let's say the same attendee goes to a workshop, AI workshop, which is running a similar program for swags. To calculate the score, the engagement score, all of this work has to be redone again, right? The reason for that is the work that was done by the t-shirt booth was not shared with the other AI workshop. So a lot of it has to be repeated. That's number one. The second is inconsistency. Let's say t-shirt booth decided that for GitHub, just giving a GitHub star is kind of an engagement, okay, as per the t-shirt booth. But the AI workshop guys decided the PR has to be merged for it to be counted as an engagement. You see the slight inconsistency between the two scores. So that creates problem when a profile is being created for you. What this ends up doing is a lot of wasted efforts for the volunteers at both these booths. And in the end, it ends up costing a lot of time and quality. Imagine the attendee who is just waiting. His score has already been calculated, but all of that has to be redone again. This was just an example for FOSSASIA, which was very relevant, but all of this currently happens in the feature store space or in the ML space, where a lot of rebuilding of the same features happens over and over again. There are inconsistencies between the efforts. Okay, so feature store, by definition, is like a system that manages, stores, and serves machine learning features. There is still some confusion about what exactly a feature is. Let's go back to the credit card example. In that example, your raw data will be, let's say, your history for the last 5 years for everything that you have purchased. Let's think of that as raw data. What will be a feature then? A feature could be a numerical value which states what was your average spend for the last month, okay? You get an idea between raw data and a feature. Another way of thinking of a feature store is as a data catalog. It's used to discover, reuse, and share features. What a feature store does is solve 3 key problems. One of them is a feature reuse. As we use the t-shirt and the workshop example, whatever calculation or whatever features were discovered and already created can be reused and can be discovered again. You do not have to rebuild it from scratch, okay? What is a training serving inconsistency? So as a feature store, it works at both ends of a machine learning lifecycle. Towards the extreme left, it will work using an offline store to kind of train your model, give it all the data that's required. And towards the extreme right, it will help the machine learning model to serve the features when it's doing the inferencing. And finally, it's about operational simplicity, right? It's about managing the feature pipelines, versioning, and monitoring, all of it in a single interface. There are a few feature stores available, but Feast is one of the truly open source feature stores that's available. Before 2017, feature stores did not have a name as such. They were used in some form or the other. They got their name in around 2017, and the name originated at Uber. It was from their Michelangelo platform, which was their internal machine learning as a service. That's where feature stores got a name, okay? Feast as a project was born at Gojek in early 2018, and its founder was William Pinar. Later, 1 year, in 2018, they collaborated with Google Cloud for Feast. It was formally launched as an open source project in 2019, jointly by GoSec as well as Google Cloud. And shortly thereafter, it was donated to the Linux Foundation. The point I'm trying to make here is Feast is not an academic project which was done purely for academic reasons. It was born in the trenches to solve real scale problems at Gojek. Here is a nice blog from Uber to see how machine learning was done at Uber. So this is a brief or a very short introduction about Feast and what components it has. I've given a couple of links which you can look at for more detailed information. So Feast registry is the #1. Think of it as a brain of Feast, where all your feature definitions are defined at a single place. Okay? Think of it as a single source of truth for all your machine learning features. Then we have the offline store and the online store. Remember, offline store is used for training. This is where all your historical data is present. This will be fed to your machine learning models when you're doing the training. The online store is used on the extreme right when your model is ready for inferencing, and features can be served at milliseconds of latency. Then we have the feature server, which is nothing but a REST API for accessing all of this. And we have a Python SDK or CLI which developers or system users can interact with. With all this background, I feel there is a unified gateway opportunity. Feast can serve as a single consistent access layer for all your AI data pipelines. Okay? We'll see why that is. So currently, organizations are facing a challenge in terms of data silos and data gravity lock-ins. As we know, data is not present at a single location, but is often scattered. For organizations, it means it's scattered across the cloud, on-prem, on the edge, and at other places. Which means that there is a lack of cohesive data story. If you go back to the technical depth paper from Google, this is where your technical depth rises because of your fragmented pipelines. For data gravity, since data is scattered and it's often costly to move your data, hyperscalers would want your data to stay in their ecosystem, right? Because that way they can force you to use proprietary tools. There is also a fragmentation problem. Let's say within the same company, there is team A, which is using XYZ hyperscaler tools, whereas there is a team B, which is using another set of tools from, let's say, another hyperscaler. What this means is it's really difficult to share features between those two teams. And movement of workloads is very restricted. What is needed is we need to simplify this complex AI data workloads. How that is possible is in 4 ways. #1 is vendor neutral foundation. You, as open source, should have the freedom to choose your infra. It could be Spark, it could be Ray, it could be Milvus, it could be Postgres. So use whatever you're using already. You do not have to switch to a vendor lock-in. The second is pipeline visibility. You might have attended many talks where the recurring theme is AI as a black box. So what you want is more and more visibility into AI. One of the ways is doing that, you should have visibility from raw data to feature engineering to model serving. The third point is hybrid deployment freedom. You should have the freedom to consistently run things across on-prem, cloud, and edge, and not just move to things to an xCloud vendor and be locked in there. And finally, since we are at FOSSASIA, everything is about open source innovation, which means contributions from multiple organizations, millions of downloads, a healthy open source project. So how is all of this possible? It is possible using a 3-layer architecture, which is data, compute, and catalog. The key part here is connect your existing infrastructure rather than replacing it with something. Layer 1 is about data sources. What it means is meet where your data lives, okay? In traditional solution, you have to migrate everything to a platform of choice. You have to move your data. And as we've seen, moving data is really costly. So what is the new approach here, right? The new approach is connect anywhere. Feast gives you the feasibility of getting your features from on-prem, from cloud, from streaming platform. And all of this using a single feature definition. The second point is cost saving. As we know, because of the movement, it becomes costly. So we continue to use our existing infrastructure. There is no migration cost or operational disruption. And finally, not all data is equal. Some will be sensitive. So you continue using your sensitive data that stays on-prem and you stay compliant. Feast gives you the option of orchestrating or giving a governed access to this data. Coming to the second part, which is compute, what this means is flexibility for every workload. In traditional solutions, lock-in is the preferred compute, lock-in to their preferred compute engine. So if you move to these hyperscalers, they will push you to use their preferred solution for compute. Whereas with Feast, you have the freedom to bring your engines, whatever you were using before, which means native support for Ray and Spark or whatever is your compute engine. It also means using open standards rather than using some proprietary DSL from some company. You have the freedom to use an open standard like Python and SQL. This really avoids going into a lock-in. And finally, top all of this, a unified catalog, which means a single interface to all your features. As we saw with the earlier example for the booth and the AI workshop, it leads to wasted hours, incompatibility, problematic feature dependencies, and there is no visibility into that. With the new approach, you have a single interface to access all your features. You get complete visibility and with governance built in. If you look at the workflows, traditionally workflows are divided between two. There is an admin who will come in, he'll set up the feature store for you, who will configure permissions, define the teams, who has access to what data, and who will monitor the operations. As soon as this is set up, there'll be a data scientist who will come in. His only job is, as long as everything is set up and have the right access, discovery of features, search for features, understanding the context, start using them. This really speeds up his workflow to iterate things quickly. What the impact here is, there is real fast innovation. Because of this speed up, you can discover and reuse as opposed to build everything from scratch, allowing you to go faster time to market. There is really strong governance because of data. You have a single point of control for your data access, for your audit trails, and your compliance. And this is across all your AI initiatives. You end up doing a lot of cost saving because you're using the same infra. You are not replacing a lot of things. And finally, the flexibility, which is about using your own architecture, which allows you to innovate without any lock-in. So in a nutshell, Feast is not just a tool, it is a missing data layer for all your strategic AI initiatives. This is good timing. Just last month, Feast as an open source project, if you see the bar on the extreme right, went to 1 million downloads in a single month, which is a first, which should tell you some idea, which should give you some idea about the health of open source project. And these are stats for PyPy. Getting started with Feast is really easy. All you have to do is pip install Feast, and that's it, you have it. You can quickly to try things out, just init a project, and you can do a Feast apply to register your feature definitions. Feast has a really nice intuitive UI. I've shared the quick start link here, which will give you more idea. But the point of this is setting up Feast is really this simple. Okay, so that sounds about what Feast is, but Feast is an ever-evolving project, right? These are some of the latest developments that are happening in Feast. It was recently onboarded to PyTorch. It joined the PyTorch Foundation. What it means is Feast can more natively work with your PyTorch workflows. Second is open lineage. Remember the black box, which AI is? With open lineage, you get visibility into your feature lineage tracking with zero code changes required. Then comes Ray, which allows you to do distributed processing. And finally, DBT. If any of you are doing any analytics, You can imagine having to redo all your DBT work when you migrated to Feast and rewriting all of those features in Python. With this integration, you no longer have to do that. You can simply point Feast to use your existing DBT stuff. Here are some of the links for Feast, the docs, the GitHub. The last link is for a blog for which I'm also a co-author. So this talk in many ways was a text-to-speech translation of this blog. If you want to revisit what I've spoken about, just look at this blog and you will find the exact same thing in the exact same order in this blog. And that's it. Thank you. Do we have any questions? Okay, thank you so much.
Thank you so much, Gaurav. We will wait a couple of minutes for those from other rooms to arrive here. All right, next up, I would like you all to please welcome Paret and Manek. Paret is a member of the technical staff at Cognitos, working on AI-driven automation. And Manek is a senior software engineer at Microsoft and a core maintainer of the Azure Cosmos database SDKs. They're going to talk for 25 minutes about scaling headless, deploying open source browser agents on Kubernetes.
Sure. Thank you. So, yeah, this is the talk. So hi, I'm Manik and Prerit. And yeah, in next 25 minutes, we'll be talking about how to create a browser-based agent and how to scale it. So so let's understand about you. So how many of you are developers here? Okay, product managers, PM, okay, platform, SREs, security. So yeah, like these are the expectations. And yeah, before we move on to, so this is just a small demo. I have to put it up in my slides, but just to give you guys a gist of it, like what it's about. So it's you might have seen a lot of websites, like they don't provide their APIs, and these MCP servers are trained, so they don't provide it. So like what we have done, we have created a browser-based agent which is going to interact directly with your browser. So I don't know whether it's clearly visible or not, but it's a very simple application. This use case is really simple. So like so so I'm traveling from India, so we need a passport, right, to enter another country. So it just checks the status. It just tracks the application. So you can just specify the details, and it's going to like spin a browser instance and then do the work. So you just have to specify it in a very simple prompt.
Basically, you just have to give, specify all the details in just an English prompt, how you interact with a simple AI agent. So just give the prompt, simply like go to this website, do blah, blah, and it will do the stuff for you, everything.
And yeah, use cases can be many. Like maybe you want to apply for a job application. So it happens, right? You have your CV and you have to like visit career pages of various companies. It could be Microsoft. So you just have to figure out like where you have to fill in what specific date. So it can do. So you just have to supply your CV and just the job IDs, and it can do the task for you. So yeah, just basic use cases of what we can do with the browser automation. So yeah, let's talk about why it matters now. So yeah, first one is about API gap. And like these days we do have like there are quite a lot of websites which don't support APIs, even MCP servers. So there could be government or logistics website. I don't know Blue Dart, but over Blue Dart also we have to like provide tracking ID. So yeah, API gaps are there, and manual operation doesn't scale well. Like you have to, if you have to fill in the details manually. And these days we do have LLMs, so they are able to understand your web page, and you can just interact with them in natural language. But yeah, models are evolving. But yeah, these reliability is little bit hard. But
Why is it hard? Because we all know AI agents hallucinate, and that's the major problem. Even though models are evolving, that rate is going down, but still hallucination is there. So yeah, that problem we have to solve. Yeah.
And then we have seen a very simple example, but yeah, let's talk about why they break at scale. So I think you all might have worked over APIs or deployments. So usually they are idempotent, right? But in in the case of browser, like there is an issue of state explosion. Like each and every browsing session is going to be different. Like they're going to have different cookies, storage, context, whatnot. And yeah, run resource pressure. Like running a browser instance takes around 100 to 200 MB. So like if you are running hundreds of browser applications, then yeah, it can break at scale. And yeah, external variants, like some of the websites can have rate limit, captchas, or basically it's possible that the website itself is changed. And yeah, operational blind spot, it's possible that there is some script which is working for you, and like the very next day it failed because the specific button is not there, right? So it's hard to trace. So yeah, there are operational blind spots. So this is where like we have used we have during our work we have developed some control plane pattern which would be essential, which will be helpful. So this is just the brief architecture of what we did. So I think you guys might. There are quite a lot of things in this slide, but just to make you understand it well, think of it as I gave you an example of passport statistic. So think of it as an call center for web APIs. So you're going to make a call. A user is going to make a call, and it's going to be answered by a receptionist, which is our orchestrator here. And then that receptionist is going to assign the task to a specific office. And in that office, there is a virtual computer, which is our browser agent. And my bad. A virtual computer, a browser agent, and a janitor just to clean up once a task is completed. So with this analogy, you can maybe understand, and couple of terms like couple of more things like HPA, ingress to load balance, scale, and we are using document DB here to just trace the state, like what all actions are performed and sessions of outcome of session. Then a UI dashboard just to check what all sessions are running and basically track like what's the status of each and every session. And key vault to store the creds and identity. And so, yeah. So these are some of the control patterns which we have identified. So first is queue-based load labeling. So like what is coming to the previous analogy, it's possible that there is a request spike. A lot of people are making calls to your API or your call center. So we can probably use queue-based load labeling just to handle that. And then back pressure and concurrency. So like we are creating pods, but we can limit the count of those pods using like explicitly putting a concurrency cap. And then auto scaling, like we can consistently monitor like what's the traffic, and based on that we can scale. And usually since a pod comes up, right, so it takes some time. So basically an image has to has to be loaded over the pod, and then there is a startup time. So we can maintain a pool of pods just to reduce the latency. So as soon as the task comes, it's gonna be served by the pod. So let's talk about one pod. So inside that one pod, a browser agent, we need a virtual display, a browser, and this browser use agent, which is going to interact with the browser, take screenshot, and basically infer like what action needs to be done. And VNC API just to debug it. So here are just the steps which you can add in your Docker image, Docker file. And this is basically the life cycle of the session. So first of all, like I have shown you the previous example of statistic. So an application can accept a task and some secrets along with it. Like let's say if it's a job application, so you might have want to pass on some secrets, and then like as soon as that task is accepted, a pod will be assigned to that along with the secrets. Then over that specific pod, that those that specific task will be executed. And then yeah, for observability, and yeah, we have to persist the data, and then the role of and last but not the least, the role of janitor comes up. So once the pod is finished, with its task, like it can be cleaned. And yeah, there's one more thing to keep track of is like we really don't want to restart the pod here, because since the browser agents are running on it, so let's say if the request if the pod failed for some for any reason, right? So we don't really want to restart that. So we can just spin another. And yeah, these are some of the SLOs, developer and PM tools. Yeah, some of the common failures which we have observed, like one is yeah LLM throttling. So um, it depends on the task. Like if it's an high request consuming task, then yeah you might run into the problem, and it can impact your entire service. Um, so since in this case we are feeding the actual images to the model to take the right decision. So like what we have figured out was we can use depending on the workflows, we can use smaller model. Sometimes if possible increase the quota, and maybe we can rate limit the specific thing. Then the next one is UI changes. So yeah, it can happen any day. So basically, we can have fallbacks. We can have scripts, and apart from that, there could be workflow control tests. Let's say your load is mostly at 9, so maybe you can run it at 6 a.m. in the morning. Just check whether everything is working fine, and if it doesn't, then yeah, you might have to update us. CAPTCHA and antibot detection, yeah, that's also one of the important aspects. So yeah, do honor retry after, and sometimes like if it's too difficult, if there is lot of friction, so maybe it's good to add human in the loop. And yeah, this like keep this antibot behavior, like if your IP is blocked, right? So like, it's an important SLO concern. It's not an script logic, because it will impact your overall application performance. Your IP. So yeah, a brief about document DB. We are using document DB here for observability. So yeah, I think most of us have worked on it. It's open source, MongoDB compatible, and it's built on Postgres. So uh, why are we using document for browser? So, we do have high velocity JSON and JSON traces, and from the pods which we are creating. So it can store it in we don't require any schema. It could be in any format, and it can run self create, and yeah, fully open source too. Yes. Okay. So this is just an example of how a session looks like. So the step one, just to navigate browser, then step like just select pick this specific select, and then yeah, click on this tag. So all traces are going into DocDB. Can be used for observability, um, or also for later debugging, optimizations also, because you can use historical traces to detect stable workflows and maybe build Playwright or Selenium script on it. Governance, and yeah, definitely product insights.
The best benefit, like why storage layer will help here, is because, as I mentioned in the starting, that AI hallucinates, right? So, and browser agent is nothing extra special. That also hallucinates. So, adding that storage layer, whenever your automation runs again and again, you have that storage layer getting better and better every time with the steps that are getting stored there. So, based on those historical traces, you can create Playwright script as mentioned. So that gives determinism to your entire automation. So things won't break at scale. So that's the added benefit.
Yeah, so this is one more optimization which we have discussed last time. So yeah, we can just so initially, like if a task is difficult, right? So AI agent is going to take a lot of time exploring like what field should go in which box. So yeah, let it explore, but we like later we can template these stable steps and then maybe write Playwright for repeatable. So I know like for the first or second floor, some time would be required, but if we are talking about a lot of people, right? So we will see significant reduction in the overall time. And yeah, if something breaks, then yeah, we can just fall back to AI. Yeah, these are some of the points why team like 6 mod, faster execution, lower cost because of lower reliance on LLM, and yeah, it's still robust to UI change. Yeah, couple of points about security, identity and secret. So we can use these secrets inside some managed service like so we have used Azure Identity for this thing and network guarded. So since the pod can access internet, right? So we have to control like we what exactly they can access. We can't allow it to access anything. Data hygiene, like it's possible that you might have someone might have added their personally identified information. So they needed to be masked and yeah, operational safety. So this is just a small rollout plan. Uh, we have added a timeline, but yeah, uh, it's not that strict. So yes, these are the final takeaways. These are browser agents are not just script, they are product capability, Kubernetes isolation, plus auto scaling for taking up the control plane decision. And then yeah, we have talked about control plane patterns like queuing, putting concurrency caps, quotas. Um, so those really help. And yeah, traces, keeping the traces or screenshots help in like helps in increasing reliability and optimization, and yeah, the hybrid approach which we have talked about. So yeah, we have used document DB, but there is also a managed offering by Azure which can be used, and then yeah, we have used browser use, which is completely open source library for this. Um yeah, thank you. Any questions? Thank you.
Right, thank you so much. We will wait just a little bit for audience from other rooms to make it here.
exactly right. Somebody's got to ask questions. Throw a question.
Whoop, whoop, whoop. All right, next up, I would like you all to please welcome Alexei. He's an expert in AI, ML, and cybersecurity who's been building large-scale backend systems for 12 years now. So Alexei is going to talk for 15 minutes about shipping ML to the browser, building real-time document detection with custom Onyx runtime WebAssembly.
Okay, thank you very much. Yeah, you missed the most important fact about me. I have 5 cats. Just an announcement. So, hello, thank you. Welcome to my talk. I'll be telling you about shipping ML to the browser. So, I'm Alexei. I work in cybersecurity in company Wallarm, and I do mostly cybersecurity. But today I'll be talking about machine learning because this is my passion, and sometimes I just like to build stuff on the internet. So, I help my friends from time to time to build interesting projects and almost some random stuff. And once upon a time, one friend came to me and told me, like, we are building a KYC product. KYC is know your customer. I think all of you have internet banks. So the first thing you always have to do is to take photo of your document, take a selfie, and some service on the backend side will compare your selfie and the document and tell you if you're a real person or not. So we had to do this, exactly that. And the problem with taking photos of documents, any other photos, like people in general do that like really bad, really bad. My friends tried to launch their KYC and they got a lot of photos of people, cats, fake documents, documents in dark room without light, documents unfocused, and we need to somehow make a validation on the client side. We need to understand if this document has enough light on it, if it camera was focused enough, and is it like a real document or not. So the first step that you need to do is to determine where is your document is on this photo. You need to detect 4 corners of the document. And the interesting thing that you cannot use backend for this. This is a very sensitive information, and also you need to do it as quickly as possible for the user. So we need to ship something right to the client. It will be a mobile browser, and that must work on medium devices such like, I don't know, 5-year-old Android, not on the latest iPhone. And of course, images stay on device and until user explicitly submits. So we need we had to do three main choices. We need to choose architecture, we need to choose output presentation, and we had to choose the most interesting part, how we deploy it. Because like machine learning, browser, I don't know, I never believed in it myself. So about the choices. First, architecture. We used Blazeface. Kudos to Google, of course. Blazeface is a machine learning architecture. It uses not so many parameters, only 200,000, which is a really, really low count in modern times, where everybody is bragging how many trillions and billions of parameters they have, but we have mobile device. We have to make it as slow as possible. Then we have a memory bandwidth bottleneck. Actually not compute, but more about memory, especially for old phones. And they have a really nice approach. It's quite an old white paper. So they, instead of standard two convolutions with two kernel launches, they use a bigger depth-wise convolution, single one, and that's why they have one memory read instead of two. We tried to use the same patterns, but of course we had something that we were dreaming of and some reality that stuck us really hard. So about our architecture, we had to choose a really, really big output comparing to Blazeface. By the way, we called it BlazeDoc. So our input image is RGB because of the spatial features of documents on different backgrounds, and comparing to faces, like faces are pretty much the same all the time. You have two eyes, one mouth, one nose all the time. Documents are very, very, very different, and conditions where they take these photos of the documents are very, very different. So we need somehow get more input data to precisely compute. So we have 108 pixels for each color, and our input is 416 or 416. That's not the most interesting numbers, but anyways, we have 100K for parameters. Our output model finally was under 2 megabytes, and inference time on desktop was 5 milliseconds, which is like really, really, really fast. We couldn't use pre-trained models or something off the shelf, because like if you do some optical recognition, you use MobileNet, you use EfficientNet, but they're costly. They take 13 megabytes, 18 megabytes, and that's not what we want to bring in the browser. So we trained our own. The unlucky thing for our product was that we couldn't use cheap direct regressions. I don't know why. Maybe we had not the best data set, because very, very hard to get perfect data set for documents. I don't know why. We tried training on that. Training was unstable. We did a lot of experiments, but it never helped. So we went for heat map regression. So each pixel votes for corner presence, spatial structure preserved. That's very helpful for documents. And we had really stable training and high precision. So this is how it looks like if you visualize it. So you have a document, and you have 4 different Gaussian blobs in 4 corners. We used adaptive loss, logarithmic penalty for defining the exact blob where the corner is. Without logarithmic penalty, you have some gradient, and with that you have almost 0 value where there is no corner, and really, really dense values where the corner is. And we did some pre-training. So we didn't use pre-trained model, we pre-trained it ourselves. We used MID 590 and 2020 datasets, and I'm really thankful to people who open sourced this dataset, because when you ever want to do any optical recognition or visual models with real documents, the problem number 1, you cannot find any dataset. People in general, they don't want to, publish their passports and IDs and driving licenses anywhere in the internet. So it's very hard to find. These guys from some university, they printed official fake documents and take photos under different angles, different light conditions, different backgrounds for people in the future, like me, to train their KYC system. I'm very, very thankful to them. So we had some pre-training on open source data sets. Then we had domain adaptation, fine-tuning, because we had our own privately labeled data set. Unfortunately, I cannot share it because of PII. And then at the last step, we did another round of fine-tuning with a hard negative mine. Hard negative mining when you took some percentage of your, so you do eval of your model, and then you have some really, really hard cases that your model cannot solve. So you take 5% of the worst cases, you add some weight, and you make another round of fine-tuning. It really helps. We just tried many different params, and these params work. Machine learning magic all the time. And here, the last part, ONNX. Does anyone ever heard about ONNX? Great, great. Thank you very much for people who didn't. That's a very complicated thing, but this is like a general standard format for machine learning inference. You can train in PyTorch like us, and then convert to ONNX. You can convert. You can train in TensorFlow. You can train whatever you want, and then convert to ONNX. This is runtime, and for browser they have WebAssembly runtime, and the only problem was that it's 12 megabytes size. Nobody wants 12 megabyte assets in the browser. So we had to work it out. Full runtime includes 150 operators. It fully supports ONNX spec, and it's 12 megabytes again. So what can you do? First, you can extract exact operators that your exact model has to use. And then you can strip everything else. So our model was FP32, and it used only 19 operators. So we don't need anything else. We have a very, very scary build, like a lot of flags, a lot of exact commands that you don't need. So we need whitelist operators. You need to remove some things you don't need in production, like C++ exceptions. You need to enable proper mode that you will use on your device, and build. If anyone wants, we have prepared Docker file publicly available with all these very scary flags, so you can just run it and get a smaller model. So we got great reduction. We get runtime reduction from 12 megabytes to 2.4 megabytes. It's 80% reduction. Our model is 1.4, so total was 3.8 megabytes, and that was surprisingly enough even for countries with a bad internet. My friends launched KYC in Nigeria, in Pakistan, but yeah, it works everywhere. And the last thing, what did we want? We wanted real-time model that will launch in mobile phone, in iframe, and it will be embeddable and will work really fast. We did not achieve that. Because of iframe, we can use only single thread, and we had on about 200 milliseconds on mid-range phone, and we had 93 accuracy in 5 pixel radius about corners, but that was actually enough for us, and we just we don't process every frame. We process it 1 in 5 frames, and that's more than enough for our KYC system. So yeah, some things worked, some things did not work. I guess it's always like that in machine learning. Yep, this is my link in Telegram if you want to connect, and this you can take a photo. It's the Docker file for building a custom runtime exactly from your model. it goes with the optimized version for browser, and it goes with a JavaScript loader that you can just include in your application and run on the client. That's it. Thank you for my talk. Oh, any questions? Yes, please.
What is the original model for your email connection? Sorry. What is the original model for your email recognition?
We don't have an original, so we have pre-trained model by ourselves. It has something like place face architecture from the white paper, but we did pre-training ourselves. So it was not fine-tuning an open source model, we did it from scratch. Maybe it was our mistake. Never do that.
All right. Any other questions?
Any questions? More questions?
Not. Thank you so much, Alexei.
Thank you very much.
All right, we're going to have a tea and coffee break now, I believe, and come back in about 20 minutes. Thank you all. This session is about how to wisely deal with language model to low resources language. So the speaker is Stanislav. He's a machine learning engineer from Zipple AI. So let's give a applause to warm welcome to Stanislav. Over to you.
Hi everyone, my name is Stanislav, and today we are going to talk about domain adaptation of large language models to low resource languages. Let's begin. And briefly about me, I'm a machine learning engineer with experience in natural language processing and information retrieval. I'm currently working at Zipple.ai, and my current project is adapting a training language model that can speak Tajik fluently, so that this language model can be deployed in government and educational institutions across the country. And Tajik language is interesting one because it combines Farsi language, which is a language widely spoken in Iran, and it's Cyrillic. So it's similar to both languages, to Russian and to Persian, Farsi language. All right. But before moving to Tajik language, let's think about languages distribution on the web. It turns out that languages are distributed very unevenly, and most popular languages take most of share in data on the web. If we take a look at statistics of Common Crawl dataset, Common Crawl dataset is a huge collection of web pages on the web, and it's basically the primary source of data for training language models. And if we take a look at languages, there are 160 unique languages present in Common Crawl. These are languages that can be classified, and Common Crawl for each web page, it tags what language is in this web page. And only English, among all of these 160 languages, only English takes 42, almost half of the share. And 10 most popular languages, such as English, Russian, German, Chinese, and so on, takes 80% of the web. And there are more than 100 of languages that share less than 0.1%. And in case of Tajik, it's even more extreme. It shares only 0.008%. So it's a very, very small amount of data. And here's the histogram distribution of languages present in the web. And as you see, English is on the first, and then we have Russian, German, and you can see how quickly languages decay in popularity. So for most languages, we have very, very little data available on the web, which makes training language models very limited. And why it's hard to train language model for low resource language? Because we don't have enough data. And according to Chinchilla scaling law, we should have for every parameter in model, in order to train language model from scratch, for every parameter in the model, we should have at least 20 tokens in our training corpora. For example, if we want to train 7 billion model, we should have 140 billion tokens. And if we want to train 100 billion model, we should have at least 2 trillion tokens dataset, which is impossible for most of languages. So the problem is, if your language is not in top 20 most spoken, most popular languages, then you are in trouble. You just don't have enough data to train language model from scratch. And then what should you do instead? You can do continued pre-training. So what is continued pre-training? Continued pre-training is when you take a base model that has some performance in your particular language, and you pre-train it on your data, specific to your domain. For example, you pre-train it on Tajik texts, or you pre-train it on I don't know, on legal documents, so that you adapt your model and you learn distribution of this particular domain, so that the model can perform better in this domain. In our case, this domain is just Tajik text. So it has a lot of advantages. First, it's much more powerful than supervised fine-tuning, because in supervised fine-tuning, you typically you may align model to some specific style, but you cannot learn much of new knowledge through supervised fine-tuning. Continued pre-training also leverages existing knowledge in other domains, in math, coding, sciences, in different languages, and it's also very useful because when you train models for your language, you probably also want this model to perform well in other domains, to be able to code something, to solve mathematical problems, and so on. On top of that, it requires much less compute and much less data if we compare it to training from scratch. So it's much cheaper and much easier than training model from scratch. And of course, there are some trade-offs because it's more complex to implement than supervised fine-tuning. And one caveat is that you also, after you do continued pre-train, you have to do supervised fine-tuning and alignment from scratch. So this is also a challenge, but it's a very fair trade-off. So that's how continued pre-training pipeline looks. First, you need to select a good base model where you can start from. And then you do pre-train on your domain data. For example, you pre-train on Tajik text. At this point, you train base model. So this model is able to autocomplete text, but it cannot answer questions. So after that, you need to do supervised fine-tuning. And in supervised fine-tuning, you train model on questions and answers. You train model on conversations so that it becomes a chatbot. It can answer questions, it can solve problems, instead of just completing the sentence, completing your text. Optional stage, which is also useful, is alignment with RLHF or DPO. But it's optional. You may feel free to skip it in some cases. And then you get your model. And one more step that can be useful, and in our case, in case of Tajik language, it was really useful, is that you merge your tuned model with original model. For example, if you do this continued pre-train on Llama 8 billion, you came up with Tajik Llama that tuned to Tajik text, and then you take original Llama instruct and you merge it. There are different ways to merge it, and we'll get to it a bit later. So the first thing that you need to do is to select good base model that fits your requirements. And it may depend on your particular use case. And in our case, selection criteria was the following. So the first thing is prior performance. We want base model to be decent at the language we train on. Because we are starting from this base model, and ideally this model should already have some knowledge in Tajik language. The other thing is model size. In our case, we want our model to be small so that it's cheaper to run inference, it's cheaper and easier to fine-tune, and yeah, so model size is really important because this model should be deployed in government institutions and also at schools. And some of these institutions do not really have good GPU servers, powerful GPU servers. So it should be deployable, should be portable and small enough. Another important thing, which is related to prior performance, but it's kind of different, is tokenization. Ideally, you need to check that tokenization, that tokenizer vocabulary contains all of characters of your language. Otherwise, your texts in your language will be broken into bytes, which is not what you really want. And this is an example about tokenization. Why you need to check your tokenizer before selecting model? Because in some cases, tokenizer will not work for your language. And here's a comparison of Llama tokenizer and Gemma-free tokenizer. And you can see simple text in Tajik, which is translated as what Dushanbe is the capital of Tajikistan. And Llama tokenizer, you can see that some of characters are broken into bytes. And tokenizer works, it's okay. LLM can work with it, but it's bad because your language model doesn't see this character as single single piece of information. Instead, it sees 2 bytes. And if you look at Gemma tokenizer, it's much better because it gets all Tajik characters right. It doesn't split them into bytes. And that's ideally what you want. You want a character to be a minimal unit of text, not bytes. All right, let's get to next slide. Another issue with low resource languages is data. And it's basically the bottleneck. So data processing and curation is very complicated. And it takes a lot of time, a lot of resources, because web data is very noisy. There is a lot of junk on the web, and you need to do a lot of processing steps. You need to do deduplication, filtering. Ideally, you should remove personal information from your training data, and it's complicated. Takes a lot of time, but you don't really need to do this because Hugging Face has recently released a new multilingual data set called FineWeb2. And this data set is huge. And this data set is a processed and filtered version of Common Crawl. So Hugging Face team did all of this heavy lifting data processing stuff for you. And you can just go and download data for your specific language, and they have more than 1,000 languages, so it's a very valuable asset. Evaluation, and evaluation is very important because if you don't evaluate your models, you cannot tell whether your model performs well, right? And there are different types of evaluation, but in this short talk, I will focus on multiple choice benchmarks. So ideally, you should have different benchmarks, and you should, if you do adaptation to some language, some low resource language, you should develop your own benchmarks. And how you create these benchmarks? One potential way is to just translate some common benchmarks like MMLU. Another way is to take exams, multiple choice tests. For example, tests about Tajik history for 9th grade, or maybe some language tests like IELTS. And it can be used to evaluate your model performance after training and during training. And the last thing I would like to mention is model merging. After you do pre-train and supervised fine-tuning, you're recommended to do merging. It means merging is when you combine multiple models into single multitask model without actually training and fine-tuning it, just by manipulating weights. And in our case, we just used linear merging, which is just a weighted average of original model and our tuned model. And the results were really good. So you can take a look at the plot. And you can see it's on y-axis, we have average performance on Tajik benchmarks. And you can see that the best performance was when we take 80% of our model and 20% of instruct model. It's quite counterintuitive, but it turns out to work best. So it's the best proportion of when you do linear merge. And that's it for today, and thanks everybody for coming. And if you have any questions, you're welcome.
Yeah, thanks to Stanislav. Due to the time constraint, we should move on to the next session. So if you have any questions, just use the backstage. Thank you. The next session is Warit. So Warit here. Oh. Right, the next session is from Warit. He's talking about the 20 million speakers. Wow. Yeah. So, yeah, Warit is from Warit is a senior research scientist from the Standard Chartered Bank, right? SCB.
Yeah.
Yeah. SCB. So, please warm welcome.
Yeah. Hi everyone. I am Warit. You can call me Boom. I am a senior research scientist from Typhoon team. We work on the open source AI. So let me first with the question. What happens when 20 million people speak a language that has no standard writing system? Today, I will talk about it. And this story, I will talk about how we solve it. Let me first introduce our team. Typhoon is an open source AI research initiative. We focus on Thai language, and we build for Thai. We share all the models, all the data set as open source. We believe that the low resource language needs open collaboration. Let's first introduce the Isan. Isan is in the northeast of Thailand. It is the region, and Isan is also the dialect. They have their own dialect, the language that they spoke. 21 million people, 1/3 of the country population, and nearly 2 trillion of GDP. So Isan is very huge and very important region. But Isan has no standard writing system. It is the spoken language. So in the digital world, if it is not written, so you are not digitally invisible because there is no writing. In the past, looking back, the old knowledge disappeared when the people who held it died. If there is no records, no papers, no storage. Today, we have storage, so the storage is not the problem. The problem is about the format, because AI read the text based on the specific way called tokens. If your language is not create or convert into tokens, you are digitally invisible. And you are invisible to the most powerful tool of this era. So obviously, we start with the engineering approach. We scrape the web, we scrape all audios, trying to do the pseudo labeling, but the data totally a mess. We try with engineering approach, but we struggle. So we cannot do anything about it because we're getting stuck due to the standard writing rules. That when we realized our mistake because we try to solve the language problems using only engineering approach. So we stopped writing code and we start studying the language to determine how can we spell and how can we attack this problem. So I would like to propose the linguistic first and engineering follows to solve this kind of problems based on the real root cause. So we did not do this alone. Our senior linguist brought in the linguistic expert from Khon Kaen University, which is very famous university in the Northeastern. So their job is to answer the basic questions. What is the words, the spelling, the sound that we should taking into consider to build something on it and to define the rules. And also, Isan is more complicated because even if Isan is the dialect, there are also almost 6 sub-dialects inside. So we start to define which main accent should be focused as a starting point. So we start with the Khon Kaen, which is the main sub-dialect, as our starting point before expanding into Thai Loi, Thai Korat, and so on. And here is the core technical problems. Not only that we define which starting point that we should do. In the central Thai language, let me make it easier for everyone. On the left side, it is the central Thai, the Thai language that every people in Thai speak, the major people in Thai speak. It has 5 tones, but Isan has 6. So the different tones, that one extra tone caused the problem because that one extra tone, we don't know how to write it. And even if the existing 5 tones, it is not aligned to each other. If you see the colors, different colors mean different pronunciation. So it's totally a mess. So our linguists trying to do the research. So in this project, the linguist is not just doing the data labeling. They also doing the linguistic research to define the rules, how to spell it. And they come up with the spelling standard by themselves based on the linguistic research. It is the logic system. This diagram is the heart of our solution. This is where Isan spelling standard starts. If you or any researchers would like to spell the Isan and try to do something about the Isan, this system can be. And we open the recipe and the system as open source because we think that this one would be a very good foundation for everyone to work on. But the spelling standard alone is not enough to do the data set, to create the ASR, to do the other stuff. Because let me show you the example, the first one. When I say the word 2,000, 2,000 is Thai language. In English, it is 2,000. Will you write it as a letter or we will write it as a number? To do the good data set, we have to ensure the consistency. So we try to create the guideline to make the strict rules for the annotator so that several annotators can annotate the same sound with the same writing. And we open source it too. The reason is very simple that we open source this transcription convention. Because if other team would like to collect the data for the ISAN or any Thai ASR, if they follow these rules, we can combine our data set together. And we can grow together instead of building the separate silo. We believe that the shared standard create the shared ecosystem. And also in the linguistic domain, we also struggle in something like different, some words has one writing system, has one spelling, but pronounced differently due to the context. So our linguists also create the data set and they map thousands of words into the IPA standard, which is for the phonetic. And we open source it as well. Both the phonetic dictionary itself and also the guideline how they create. After we get all stuff about defining something and the related stuff for ISAN, we start collect the data. We use 3 methods. The first one is the question answering. We try, instead of getting the reading script, you put the reading script to let them say the word. We try to do the question answering to get the natural conversation. And the next one is the scenario based. We try to create the dialogue and let them feel what they want to answer. This one is to get the real situation and the real sentence from them. And the last one is the visual question answering. We show them the picture of the local culture, local food. This is to push out their vocab and what vocab that they usually or they actually use in their real life. After we collect the data, we got this one, ISAN speech corpus. So it includes audio files and the high quality transcription. The transcription that is based on our spelling rules and transcription convention rule. And we open source the corpus. So you can easily access them via this QR code, and I will show you our website at the end of the slide. After the data collection, the definition of ISAN, coming up with the ISAN spelling standards and the conventions, we took our stuff from linguists into our engineering pipe to build the model, to build the ISAN ASR model. And here is the performance of our Typhoon ISAN ASR. We achieved the lower character error rate than another open source ASR. We try to fine-tune another ASR using other dialect dataset, which has no definition or spelling standard. So in low resource setup, the quality beats quantity. So our spelling standard can improve the model, can improve the model performance. And imagine if you have the ASR is for the listening, and after we got the pairs of the audios and the text, we can also build the TTS. So imagine if we can have the inclusive voice AI agent that can listening to ISAN, to the dialect, and also can say the dialect, can say the ISAN. So let's see the demo together. archive to read our technical report on how we built all of them. Okay. So let's say is that from the inclusive voice agent, what I mentioned is no language should be left behind. So at Typhoon, we try to empower Thailand AI future. So we try to preserve, to protect our language, our local identity by building the AI model and artifact as open source. Because we believe that doing the low resource language, the Thai language by ourselves will protect all of the culture. The models and the data in the website, the models are yours, the data are. So let's build the AI open source community together. Thank you very much.
Yeah, thank you, Warid.
Maybe
oh, another one? Oh, yeah.
Another try.
Another try.
But fail. That's okay.
Not yet.
Everyone can access to our website, opentyphoon.ai. So that, and also join our Discord. So if you interested in Thai open source AI or other language as well, we are very welcome to collaborate and to talk. Yeah, thank you.
Thank you. Thank you. Please give him a big clap to Warid. So thanks for his session. Do you have any questions? We have a few minutes. Okay.
Thank you. I just wanted to ask about your errors. You sort of had an 8% error and a 10% error. Do you have a sense of which stages? So you have these 3 stages, right? I don't know exactly what you're computing the error from here, but do you have a sense of where the biggest errors are? For example, is it in transcription? Is it in the LLM reasoning? Is it in the, if you see what I mean?
I think the problem is, let me deep dive into the models a little bit, because this ASR model, we adapted from the central type because we can only manually collect and manually labeling the data. So the data is not that much to train it. So we stack with the central Thai. And also, as I mentioned, that Thai has 5 tones, Isan has 6 tones. So it's quite a mess a little bit during the training, but that is our best effort to try to build it and to train it. And also we also include this kind of the error analysis in our technical report that can be accessed from our website as well. Yeah, thank you.
Yeah, we have one more question if there is. Anyone? Okay. Yeah. Oh, yeah.
Okay. Hi. So just want to ask, like, let's say Isan is quite have a lot of dialects and also like specific words. Is that included on training within the ASR model, or like any tricks or any technique that like to be like detect on that dialect or maybe like detect on that word?
Actually, during the training, we stack the Isan with Thai language as well to adapt the data. And if we have more dialects, so let's follow the recipe, like start with the spelling standard and other stuff related to the language first, and then we can continue doing the engineering approach and do the trial errors and experiment. Yeah.
John?
Thank you. So my question is, manual labeling is a very costly process in both in money and in time. Can you estimate like how much time and money did you spend to label such corpus? Because it's a great thing, but
Yep.
it's the biggest problem, I think, all the time.
Yep. So for the budget, I cannot share about it exactly.
Just estimate.
Estimate around, I think, 1 million baht, around that. And for the time spending on building the rules and the guidelines, around 4 months to 6. The labeling process can start simultaneously, but with the error corrections and a lot of stuff, it's around 2 months. For the data collection, to 4 or 5 months. So exactly almost 11 months.
And in terms of your team, how many people were labeling? Because that's a great task.
Our team, the structure, 5 research scientists, 3 engineering, 1 full-time linguist, and around 5 or 6 part-time linguists. So it's not quite a lot, but it's our effort.
That's serious. Thank you very much.
Thanks.
Thanks, everyone. Yeah. Oh, yeah, he's leaving. So, yeah. Again, please give a big clap to Rarit. And the next session will be another one. So, just give a second. All right, this time we are using, the session is about the localization. So how can we use local language model running on our local server for the localization? So please give a big welcome to V.
Localization and translation is a big opportunity for me to have some activities with Thai KDE communities, although although no one need to code in C++. And in localization, the minimum requirement, people should know English and Thai, right? And what is more difficult, more essential is consistency. Consistency is essential, but in many cases it can be boring. So, KDE Thai localization has more than 20 years of history. However, languages keep changing from time to time, and target audiences evolve. Some word like file, we translate in Thai as fam. Nowadays, many people doesn't use this word anymore. And we can't browse translation history. We can have translation memory, but there is no information whether this one was translated 20 years ago or just a few years ago. Maybe what come into our mind as a software engineer or programmer, maybe we can use Git blame, but we cannot use Git blame because in KDE L10N, they use the tools called Scripty to edit the localization. So when we use Git blame, most of the time most of the lines are edited by Scripty. So we don't know who was the original translator. And we can even use Git because KDE L10N is still based on subversion. So we need a better way to track human translation history. So our solution, we mainly use shell script to extract translation history from subversion and extract log, but we exclude scripting and pass the gettext files and put it into Postgres so we can search the history. First one, we checked out the localization for Thai, which basically is a pair of English and Thai, which will show on our computer, right? And the next one, we use SVN log to check what has been changed, and we exclude scripting and pass the result. And we traverse all the files because there are a lot of files in KDE L10N. There are files for most of application. Then we can extract using the command svn cat. We extract every version, every revision, except that the one that made by bot or scripting. Then we process all the file, which is in this case is .po for gettext, and we store it in the database as simple as this. Besides source text and target text, which we usually see in the translation memory, we also store revision number from subversion and modified date time from the subversion as well, and also committer, which should be the translator. So from this, we can query by Postgres, who is the committer. We can check the same source text and what is translated. And we also count the usage. This one, we collect all the translator and the word usage. And finally, we select some of them from the overall, we want to find the variants of translation, which the Markov time that we use. And from this, we write a bit of shell script to make it ready for agentic coding tools. In this case, I use OpenCode. When we have shell script, OpenCode can call the shell script directly without having to write MCP or anything else. So most of the time, the script is just connect to the database and retrieve the query and format it into format that human and AI can understand. And the most important information, we want to check the latest time and the committer. Here is the example of the prompt I used. We can ask the OpenCode with Gwen 3.5 to translate Thai of the word stop movie by searching the translation example using the shell script that I have already prepared, and it can do, right? This is the example of the result. it also find another word. For example, stopped. Stop just translate only 3 months ago, so it is recent enough, so we can use it. And stop playback translate last year, and also similar one. All of them are new, so it we good to go. Another word, what movie. Movie, we have some varieties. Some of them are translate 9 years ago, and some of them even translate 14 years ago. Maybe we have to be aware of this. As you can see, this history is important for AI to decide which one that it will use in the translation, and it's also important for us human to check whether the example that we use as reference is recent enough. And here is the response from open code. It is also consistent with the example. It can find the correct translation. And it also provide more alternatives option as well, which we can choose based on. And another approach that we can use besides just use I like in SQL, we can convert the text into embedding and store it in Postgres. Postgres also provide the facility for query embedding vectors easily, and then we can use as well in the prompt that I have shown. Most of time, cloud AI nowadays is very cheap and very easy to access, but local AI guarantee our safety, because nowadays we have a lot of uncertainty. So I want to make sure that I can use this tool purely locally. So I had a few experiments with Olama, and the model Gwen 3.5, 2 billion parameters. And it works on my laptop, also it is very, very slow. And the trick that we should do is that we should tell Olama to extend its context range to more than 200,000. So then it works. Otherwise, it cannot call our tools. So by this approach, we can check our translation history from 20 years ago and make use of AI tools. And also, the tool itself is useful for human as well. And there is no scientific comparison yet. You can download all the code here. And that's all. Any question or comment?
Any questions around this session? No? Okay. Yeah. Thank you, V. Please give him a big clap. Oh, okay. One more.
Just wonder if KDE also have the, I mean, like in some localization databases, right? Like for example, I think in Transifex, in WebLate, nowadays you can actually have the some more context information whether like this string going to be used, or for example in a button, or or how many characters limit for a particular string, right? Because like on the screen, right, you have limited resources. Not sure whether like KDE provide this kind of context for the translator or not. That AI probably can use to make a decision.
The answer is I'm not sure. but we can see from at least we know which file that is from, so we can at least guess from that. Yes, I know that. Mozilla provide that for us, but I didn't see exactly the same thing in KDE. But at least KDE, we can guess from the file name.
Any other question? No? Thanks, P. The next session will be starting in 5 minutes' time. So, right. So this is the second last session of this track. And coincidentally, this session and the last session is about the healthcare industry. So please, I'd like to invite the TT-Part to give the text to speech to image for his the medical workflow. So please welcome the TT-Part.
Yay. Hi everyone. So yeah, thanks so much for having me. So I switched my talk a little bit. Like today we will talk. I mean, it's the same talk, but yeah, I'll tell you about like how we build like open source tool and models for science and clinical workflow. So my name is Titipat, and I'm an assistant professor at like the Department of Biomedical Engineering at Mahidol University. So if you are interested in some of the work, like you can see in my GitHub, like Titipat A, or like you can see our website also. Yeah. So yeah, I mean like many talks, right? Like have been talk about like how you train your models. Like I think like one of the steps that we need to do, right, is like you probably like need some data, right? And then some of the talks already like tell you a little bit that you like have to gather some data, right? And then before you have some data, right, like you probably need some tools, right, to like scrape those data and then like format those data before you train the model, right? So like in my work, right, like a lot of my work is like also involved in like building tool for science. So this include like building some recommendation engine that we use for a large neuroscience conference, like including like SFN conference, if you everyone know, like so we have been building recommendation engine since like 2016 roughly, that we built like this recommendation engine to use in like a largest neuroscience conference in the world, and including like some matching algorithm that we do in science also, right? Like so like this matching algorithm, like including like paper to reviewer matching. So when you submit the paper to like the conferences, right, like we use like this system to basically like match the paper to reviewer based on their expertise, right? And then the matching event that we host, like you can see on the top right of the slide, right, that we do, like we actually do in person like matching where we like basically like put the table numbers in their like name sheet, right, like the name tag, and basically like each 15 minutes, right, they have to go to that table, and then they'll see like another researcher that do like similar research, and then they can talk, right? So these are like kind of the tools that I built for science, right? So these kind of tool, right, like you basically you can think about it like you need some data, right, to basically like scrape these data. You need to train some embedding models, right, like that we understand today. Like if you use like language model, you can like take these data, maybe like they abstract into like embeddings and then like match them, right, using these embeddings. So yeah, these are kind of like the backbone things that I do. So, and basically like we need these embedding models for scientists, right? So as I mentioned, right, like these kind of tool, right, we need like to pre-train, right, these like embedding models. So when you need to pre-train this model, you need a lot of data, right? Like, and most of the data, like, I mean, we need to use like Medline data, right? So, I mean, just to recap, right, this is the kind of tools that we build for science, right? Like we do matching algorithm, and then like we have like this matching algorithm in like the conferences, and then also like summer school, like including like NeuroMatch conferences. So this kind of like the things that we do is like, I mean, you can think about it as like having some distance, right, between like all the people that you want to match, and then you want to like try to find some assignment matrix, maybe B, that try to find like these matching between people, or maybe like between paper to reviewers, right? Like using like some of the like linear programming. So these are kind of the thing we do, right? So to kind of pre-train this model, you need a lot of data, right? So that's why we built this like PubMed parser, which is like a parser to parse like this Medline article. So to give you guys some overview, right? Like National Library of Medicine, like from NIH, like they like release these Medline corpus, right? Like so it include like 38 million like publication now, right? Like 38 million publications. So like they release this in something called XML format. and then they built like something called like PubMed, which is like a search engine that allows you to search for to these publications, right? And some of the subsets, right? Some of the subsets of Medline, like or this like Medline articles are something called like PubMed Central Open Access subset, where like people like release all the full text of the paper, which is under CC license, where you can like use to pre-train the model also, right? So these XML format is like really hard and like directly used in Python, right? So we create like this PubMed parser where after like you download these XML formats, like whether it's from the Medline, maybe you like scrape it from PubMed, right? Or maybe you like download like all the full corpus from like PubMed Open Access. You can just pass it in Python, and then you get the JSON format that you can use directly. So these are kind of like the things that I mean, we have been using this for a while now. I mean, after I transitioned back to Thailand, I don't have much time to maintain this repository. So like I call for maintainer. So I think I just want to shout out to like Niels Herman, like Michael Rose, like from Max Planck, that like they take on the project and then now like they maintain the library for me. Like, so thanks to open source community and amazing people here that they keep maintaining like PubMed parser that people can still like parse like all the increased volume of like Medline articles, right, for pre-train the models, right? So get back to like this embedding models, right, that we did back in the day, right? Like now people have been using PubMed parser to like many things, right? Like including like biomed clip, like where Microsoft Research just kind of like parse this article, right? Like, and then you have like a caption and then images, right, from the articles. So what you can do is that you can train like a clip model, right? Like where you can match like these images to the captions based on like this symmetry matrix, right? Like where you want to try to match like this image encoder to like the text encoder. So you see like many great work that like use PubMed parser to parse like the data from Medline, and then people use. Another one like example is like Biodex, where they parse like information about like adverse drug event attractions, and then they use it for like seeing like, oh, like what are the drugs and like what are the patient type that like needed this drug. And then also some of them, right, like that we do is also like parsing the full PDF, right? So like let's say like if I have some PDF, like we also build like something called PDF parser, where you can like take this PDF, full PDF, and then parse it into JSON, where it connects to something called Grobet, like that it can parse like the full articles, and then you can also like do object detections to extract like these images from like the full PDF, right? So when we do this, right, we can like connect to things like what people do today, like review agents, where they like just like send the full PDF, right? They parse it using like PDF parser, and then they have like the full content where the review agents can like look into like this whole content and then try to review the paper, right, for you. Like, but like, I mean, you don't do it fully, right? Like, I mean, you do it with care. Yeah. Anyways, yeah. So yeah, these are kind of like the tools that we can gather like this medical information and then like medical publications, right? But when I transitioned back to Thailand, like there are also great amount of data like that we see in clinical workflow, like, but like in the early days, right? Maybe like 3 to 4 years ago, like before Typhoon released like the speech to text model, right? There are not many groups that are doing like speech to text model and then like all the clinical like workflow in Thai. So I built this speech to text model for Thai, like we call Thonburian Whisper, where we basically like fine tune Whisper that we gather like data, like including like common voice data. We gather data from like GigaSpeech, which are like open data, right? Like we do some cleanings, like text cleaning, and then we use that for like fine tuning like the Thonburian Whisper, where now like we can like gather more information from like clinical workflow, and then we can use it later, right? So after like I mean, like let's say like if you have like the speech to text model, you have like the Thai text, right? And then some of the problems that people also mentioned in this session, like is that like when you do the data, right, like you need to like tokenize Thai text because like Thai text doesn't have like this space, right? So some of the problem that we need to do is like also we need to build like these tokenizations, right? Whether I mean these days we have like multiple tokenization that we can use, but DeepCut is like one of the models that I built like based on deep learning, right? Like it's a deep learning models that train on like this tokenization data where we can like tokenize this text and then we can use to measure like word error rates of like this speech to text model and I think like DeepCut is still like one of the models that people choose to use when they want to evaluate like this speech to text model. So yeah, you need like a lot of like components, right? Like I what I try to say is like you need a lot of components to build like these things, right? Like so that people in like the community can use like and yeah, like I mean thanks to like most of the team now, like including Typhoon, like NegTech and the Atapon group, they also like release these like tokenizations, like the models now that are open source that people in the community can use. So it's great to see like things that people build and use for Thai also, right? So for Tomburi and Whisper specifically, right? Like we have been like sending the models to some of the applications like in Thai where like we can we use Tomburi and Whisper in like DMI applications where people can like call like the hotline, right? Like the hotline for depression assessment. So basically like when they call the hotline like 1323, probably like 1323, when you call it, right? You can talk to like this chatbot assistant where they will like I mean evaluate like your depression level based on like this AI chatbot. Like they have like some questions, right? So like they use Tomburi and Whisper to like transcribe the text, and then they build their custom models to like re-rank the depression level, right? And then they can like I mean re-rank these people that has like high chance to have like a high depression level to talk to the doctors quickly, right? Another application that also like use our models include like Prescribe. Yep, that we can like transcribe like the conversation between doctor and patient, and we can summarize into like a SOAP note, like SOAP note that people can use and then summarize it into like medical I mean medical transcript. Yeah. Anyways, yeah. So and then like shout out to Typhoon team also that they also use like our models like Whisper large model to like kind of like do like parallel labeling with other models that community release, right? And then they use it to like fine tune another models, right? So these are kind of like things that you see that you can basically like takes on like a lot of like data, right? Like by building like maybe like speech to text model or like the text parser models that you can use it later on in like your AI pipeline, right? So my take is like you don't have to solve everything. Like you build tools that help everyone, and then another one is like you build open source tool, right? Like also allow you to have like collaborator around the world. So that open source is great. Yeah, I think that's all my talk. Thank you so much, everyone. Yeah.
Yeah, thank you, Titipat, with a great the talk. Any questions around? Okay, just hold a second.
Yep. Who here? Yeah.
Yeah, thanks for the nice talk. I was interested in the depression assessment example that you gave a few slides back. And it made me think LLMs have been, unfortunately, many cases of people getting themselves into a rabbit hole where it's led them to terrible places. Mm-hmm. Have you thought about whether any of the work you've done could be applied in a general AI safety sense to help users?
Right. I believe so. Yeah. So like, I mean, yeah. I mean, like for us, right? I mean, for like the DMI team, like not, I'm not like doing like the model with them, but yeah, basically like we need to like assess a lot of like the models, including like speech to text model, and then they themselves also like need to like do like this like re-ranking and then see whether like this maybe like re-rank like people to like maybe lower tier of like depression, right? Like, but we see that a lot of people like when they talk to like this chatbot with like questionnaires, right? Like it like help them a little bit, like so they don't have to wait. So basically, like they just like do this like questionnaires, and then like I mean, if the questionnaire say like, oh, you are good, right? Like yeah, they can like hang up, or like you can wait after like you do this questionnaire. So I think like now we have like maybe like 500,000 people using these hotline, and then like by like doing like this AI automation. But yeah, like I think safety could be like a crucial thing that like we need to also like see, right? Like I mean, these are kind of like in the test environment now, but yeah, that like I mean people can choose, but yeah, we need to evaluate like quite a lot also like in terms of like models and also like the safety. We have another question in the front probably. Yeah.
Hi, could you talk about how you test the medical model?
Yep.
Because it's Thai
Yeah.
language.
Yeah.
What is the maturity of testing
Right.
models that
Right,
speak
right.
Thai medical conversation?
Right.
And where do you find information about its accuracy?
Yeah. So like we test this. We actually test this in like in terms of summarizations. So after we summarize it, right? Like so we actually test on hallucinations on the models, whether like the model hallucinate. Like so we do like a percentage of hallucination per bullet, right? So for each one, like we will have like a ground truth labeling of like when the doctor summarize, and then we see like the AI summarizations. We see like the hallucination rate, and then the kind of like the what's it called, like the content, right? Like whether like the content is like all included. Like so we test on recall, like a lot, like where like all the information here is like related to what doctor is speaking, right? So hallucination means like sometimes like they speak the age, and then like it hallucinate to like one like different numbers, right? Things like that. So actually like doing like maybe when you have like the full transcript, right? Like the full transcript, like the correct transcript, and you send to language model, right? You will still see like probably like 5 to 6% hallucination from like the models, right? Like so like let's say like if you summarize into like 100 bullets, like 5 to 6 of them like will still have like some hallucination. So with the noisy transcription also, like you may get into like 8 to 9% or 10% hallucination. So those are the things that we test quite a lot. And then also like, I mean, we also test in like each modules, right? Including the speech to text word error rate. So for the medical domain, I would say like it will be around like 15 to 20 word error rate for Thai. For the general domain, it will be like 10, right? Like it will be 10 like word error rate in general domain. For English now, like the numbers will be like 5 to 6, right? So for Thai, it's like around 10 to 15, depending on the field. Yeah. So medical domain is like 15. Yeah, I would say. So we test those a lot, and yeah, we test like each component and also like downstream summarization. Yeah.
Right.
Yep.
Any more? Oh,
one,
yeah. So
one more
just
question.
one second. So this will be the last question for this session.
Yeah, talking about the error rate, do you have some process of managing that error rate in the field, or do you just track it, or you have some automation where you manage to push that error rate down a bit in production?
Right. So I mean, like we have collected a lot of data. So yeah, like we have like some actors that like doing like conversation with like active patients, right? And then we use that for like a kind of like the ground truth for us, right? Like after we do like these transcriptions, like we also test on like this data. Yeah, I mean like that's kind of the process. Like so this data kind of like expand quite a bit, like because like we need more cases, right? Like so we just keep collecting in batch, I would say, and then like we test the data on like new kind of scenario. So not sure if like that fully answered the questions, but yeah, we have like those pipeline.
Okay. Thank you.
Right. Thanks, Titipat, again.
Thank you.
Yeah, please give him a big clap.
Thanks so much.
So right next.
Testing.
Right. So this is the lucky last session of this track. I'd like to invite Melvin. He's talking about how to use AI and machine learning technique into their healthcare prediction system. So please give him a warm welcome.
So good evening, everyone. Thanks for being here. So my name is Melvin, and my Chinese name is Huang Chong Idongis, and I actually am a registered clinical informatics pharmacist. So if you're wondering what is a healthcare professional doing here in a tech conference, it's because I'm also the CTO of Health Predictive AI, and my academic credentials are as follow. I graduated with a bachelor's, and then subsequently I went for my technical proficiency diplomas and degrees. And for those who want to follow on my socials, you can take a look. Okay, so essentially today's session will be talking about building health predictive AI, an AI/ML health prediction system that we developed at NUS using open source tools. And the agenda of today's session will be actually 6 different topics. Introduction to the problem, introduction to our team, the problem that we are trying to solve, the solution that we came up with, and a short demo. And next, we're going to talk about the impact that this particular product has and the future vision of this product. A quick introduction. So a little bit more about myself. I have actually about 15 plus years of experience across technology, education, community, and healthcare sectors. I'm actually a dual qualified software engineer and developer advocate, and I've actually working experience across 9 different hospitals and community pharmacies in Singapore. And I primarily work in the IT and clinical field. And my education-wise, I graduated from the NUS, which is a top university in Singapore, as a valedictorian with distinction, which is the most outstanding postgraduate student. And also, I previously did my FYP at NUS Medicine, and also got my degree at NUS Pharmacy. And some of the recognition you can see, previously I was offered a accelerated 2-year PharmD clinical doctorate sponsorship by MH due to my outstanding performance in the national exam. And I recently participated in the Oracle Race to Certificate Challenge, where I got the 99.96 percentile out of 1 million competitors and out of 160 countries. But more about my team. The Health Predictive AI team actually consists of 12 software consultants, and we are spreading impact across 7 different countries. And just for information, we were actually accepted into the Microsoft for Startups program. And I'm leading the project and product as the CTO. Mr. Yan Pang is behind, my data science manager. Anthony Huang, who is based in Mexico and USA, our ops manager. Ms. Zing Wang, which is basically our product owner and software engineer as well, and also doing UI UX. And Ms. Eileen, which is basically our business analyst and software engineer. Fusin, our software engineer and QA tester. And Mr. Rick Wu, which is our senior software engineer. Kyler, doing both software engineering and UI UX. Sam, doing software. And Victor, doing research software engineering. And we have Chun Fang and Lilian, doing marketing and outreach. Now, the team at Health Predictive AI actually comes from a diverse academic background. We actually come from leading universities and colleges in Asia and the United States. So we are representing universities like, for instance, Georgia Tech, which I'll be matriculating in this year. And also universities like, we are alumni of universities related to, for instance, like NUS ISS, and I mentioned that previously I was doing my FYP at NUS Medicine and got my degree in pharmacy and so on and so forth. And most notably, many of my teammates are also based in China, and they graduated from the top 985-211, which is basically the China Ivy League C9 equivalent university, such as Fudan University. Now, Health Predictive AI actually started out as an idea for my postgraduate capstone project, or commonly known as final year project. And from an idea, it became an startup with an early impact, and this is something that I want to share in this particular conference. So this project actually was awarded the distinction at NUS, and these are my teammates. So 8 of us, top postgraduate students, we had a vision that we wanted to blend healthcare and technology to improve the lives of others. And this is my team. As you can see, we were having fun and actually working on our product. Now, the startup life itself, for those who are in startups, actually is about working hard and playing hard. So as much as I push my team to push the limits of our productivity, I also make sure that our team plays hard as well through various rest and recreation activities. Now, the problem that we are trying to solve. The issue here is that at the core reality, healthcare itself, these three diseases, diabetes type 2, hypertension, and hyperlipidemia, these are all strongly influenced by lifestyle modification, and they can actually be preventable if early detected. However, most detection actually happens late. And what happens when detection of these problems become late? As a result, these chronic diseases become silent killers. Now, these are statistics that are actually taken from the global healthcare organizations like World Health Organization and World Heart Foundation. 830 plus million diabetic patients around the world, 1.4 billion hypertension patients. 39% of adults here in the whole world have high cholesterol. These statistics tell a worrying trend. Billions of people actually suffer from one or more combinations of these diseases. And what's the impact on us? It results in a significant loss of lives. Combined, diabetes, hypertension, and hyperlipidemia result in 15.6 million lives being claimed annually. And for those who are surviving with those conditions, what does it result in? It results in high medication burden. Our team has combed through tons of research papers, and we found that polypharmacy is an issue in patients suffering from diabetes, hypertension, and hyperlipidemia. And on average, they take 4 to 10 medication types. Imagine that amount of medication, that large number of medications you have to take. It will lead to adherence issues and resulting in adverse patient outcomes when you don't take your medications on time. The next slide will be a bit gruesome. I warn you guys. So what are the complications of diabetes, hypertension, and hyperlipidemia? I highlighted 3 of them to make a stand. First of all, diabetes, one of the most common things I see in my clinical practice is diabetic foot ulcers. To summarize, breakdown of skin and tissue, and in worst case, if infected, it can lead to nerve damage, bone infection, gangrene, and amputation. This is not a joke. In the clinical practice, I see it many times. Due to improper diabetic medication treatment, they did not take their medication, it resulted in this. For those who are suffering from hypertension, one of the common things that I see in the clinical practice is resulting in hypertensive kidney disease. As you can see from the slide, I'm not sure you can see it clearly, but essentially, the kidney is not supposed to look like that. This kidney is clearly scarred. And the hardening and scarring of these kidney tissues can result in end-stage renal failure, which results in a cocktail of medications that such patients have to take. How about for coronary artery disease? When you eat too much fatty food, the fatty deposit inside your blood vessels, result in the plaque, and the narrowing of blood vessels can lead to heart attacks and strokes. Healthcare itself is a very reactive system still. After symptoms appear, then we diagnose. After progression has happened, then we intervene. And only when damage has been done, healthcare then starts. In fact, we are racing against the clock. So the solution that our team has come up with is Health Predictive AI. And we are proud to basically be accepted in the Microsoft for Startups program. What exactly, in a nutshell, is Health Predictive AI? It's an ML-based disease risk prediction engine that we securely deploy on the cloud with full-stack platform for healthcare tracking. We also integrated a research-grounded RegLM healthcare assistant, and this is designed for early disease prevention with personalized healthcare insights. And our motto at Health Predictive AI is, your health, our priority. Now, this is a simplified architecture so that developers of any skill sets, be it beginner or advanced, can learn something quickly in this short 15-minute session. 3 layers: web presentation layer, logic layer, data layer. So certain open source technologies that we can use are like, for example, front end for React, Kotlin for mobile, we also have a mobile prototype. And also for the backend server, you can use technologies like Spring Boot and Spring Security. And for machine learning, you can use like Python, Pandas, Scikit-learn, Flask, FastAPI. And for backend, you can use open source technologies like MySQL. Now, these are our model performance that we train at NUS across the different healthcare conditions. I'd like to focus on the last column here, which is the K4 cross-validation score. So for our diabetes, in terms of the K4, we did a K of 5.4 cross-validation score, the matrix with the accuracy. And we got basically, for diabetes, 95.3% accuracy. Hypertension models, 99.49% accuracy. And for decision tree, we got 99.86% accuracy. Now, the high accuracy here, based on our findings, can be attributed to us translating clinical domain expertise into actionable features. And this feature engineering, we believe, is the most critical step in creating a reliable, accurate, and trustworthy medical AI system. Now, our team has religiously followed this 10-step framework or workflow for building high-performance AI ML models. the first thing we need to identify is what exactly is the business problem that we are trying to solve. In our case, we are trying to help caregivers and patients basically manage their health. So this is a potential market that we want to go to. Next, we went to ML problem formulation, develop diabetes, hypertension, hyperlipidemia models, and then after that, we extract, transform, and load the data. Finally, moving on to EDA, whereby we see if we can identify any trends. The most important thing I want to highlight is step 5, which is feature engineering. And this is where actually my clinical practice and also my clinical friends can actually come into play, whereby actually in the healthcare industry, many clinicians are actually helping out with data annotation. Experts at healthcare can actually help to train AI/ML models and improve the accuracy based on our clinical expertise. Next, you select the algorithm, can try around based on different research papers, evaluate using various metrics, accuracy, precision, recall, F1 score, cross-validation score, so on and so forth. But moving on, you need to fine-tune the model parameters, hyperparameters, and if business goals are met, then we deploy, and we retrain if there's model drift or new data. If business goals are not met, we select another algorithm, we can do feature augmentation, or we can do data augmentation. Now, our recommended system is actually grounded in peer-reviewed medical research and established clinical findings. Most notably, we reference to Nature Reviews Cardiology, and this is a very high-impact journal paper, where me and my team, we comb through these various medical references, and we actually integrate the logic in our recommendation system. And likewise, our REC-LM healthcare assistant is also research-driven and also based on locally contextualized intelligence, whereby we got localized guidelines from MOH, ACE, CHARS, and we integrated in our knowledge base in our chatbot so that this reduces the hallucination risk and minimizes the AI/ML generic responses. We also decide to showcase our open source powered DevOps architecture. For those who want to look at the details, you can actually skim through the bottom notes after the presentation. But just a quick summary, when the developer checks in the code on GitHub, it will run our CI pipeline. And the CI pipeline will run various GitHub actions linked to various static code analysis or software composition analysis tools. Once passed, the front-end and back-end pipelines for CD will basically run to deploy the apps on the web. Health Predictive AI actually mentioned is actually a paradigm shift because we are trying to transform healthcare from reactive to preventive healthcare using AI/ML. Because when you go for AI/ML conferences, they publish a lot of papers. The question I have in my mind is, what's the clinical significance of this particular paper? And that's what we're trying to do here, because we know that using AI/ML, it can actually enable early risk prediction of diseases through probabilistic risk scoring. And with these tools, it can empower individuals to get preventive insight so that they can approach their healthcare professionals, like doctors, like pharmacists and me, and get the correct advice to reduce the long-term burden. And why are we sharing all this information? Because at Health Predictive AI, we believe in open source knowledge. Even if we fail in our startup, we still want our work to matter. And for a matter of fact, 90% of startups will fail. And when we share our insights, others can build on it so that we can actually advance preventive healthcare with AI together. And we don't want our impact to end with a company. We want the knowledge to compound in the open source community. A quick demo. For those who are interested, you can just go on the website after this presentation, healthpredictor.ai, to check out our AI-powered health predictions. The impact that we have. Looking back, we never expected our product to actually become a blueprint and learning model for builders worldwide. Including this conference, it's actually have been presented at 4 conferences and tech events across 3 different countries. And the numbers I have shown, 5.4 attendees from 50 plus different countries. And also, I shared this product in developer communities like your first open source project. So overall, there's about 6,000 people who are actually using this as a framework and blueprint for learning. Now, for those students in the crowd, or for those who have links to students, as a developer advocate for representing GitHub education, free offer here, so go to github.io/FOSSASIA to actually get free GitHub Pro. Benefits of GitHub Pro, you can use it to write docs, you can use it to basically write and fix code, and you can use it to write and fix your unit tests. So please go to the link here, github.io/FOSSASIA26. Now, the future vision of this product is that we are a very early stage and research-driven startup, and we are still conducting global sentiment research, and we're trying to refine our product market fit. And we're looking to explore institutional collaboration, and on my end, I'm actually reading research papers to actually expand beyond the validated models that we have, looking at some of the state-of-the-art research. And overall, we want to contribute to preventive healthcare at a scale. The lessons learned, in summary, we learned that we should not focus too much on machine learning accuracy, because when you talk to end users, they don't understand all the machine learning accuracy and evaluation metrics. What they believe matter more is on clinical grounding. Is your product backed by science? And when you do preventive healthcare, preventive AI, it carries a lot of responsibility. We must remember, technology must serve people, not our egos. And through this project, we had a lot of engineering trade-offs and bottlenecks depending on our fluency with the various tech stack. So for everyone in the audience, please help shape the future of preventive AI. Share your voice. The first 10 to actually complete the survey in person and present to my data science manager at the back, Mr. Yen Pang, can actually redeem a GitHub token of appreciation. So these are the links here, or you can find us for the links later if you want to get your free gift. So I thank everyone for your time. And remember, it takes only one health issue to stop everything. Take preventive action today. So for those who want to follow on my socials, GitHub, LinkedIn, and inquire more on email, you can contact us. Yeah, but more active on my NUS email. Yeah, that's all. Your health is our priority. Thank you.
Yeah, thanks for the great talk. Do you have any questions?
If you have questions, you can find me later, because the survey, we are doing the survey and can collect from us and ask the question on the spot.
But this is the last talk, so we have plenty of time.
Yeah, for those who want to do the survey, can find us later and ask the questions also. Yeah. Oh, you have a question? Okay, please.
The health issues you addressed, they seem to be also connected to, or preventing them seems to be connected to changing an individual's habit. How are you approaching like a distribution towards, or like, how are you approaching dealing with those health issues? I mean, you analyze them, and like what the...
Can I rephrase the question? Are you trying to ask like, how are we dealing with like diseases across different age distributions? Is that what you're trying to say?
Excuse me?
Are you trying to ask like, how are we dealing with, and is your question, can I rephrase the question as like, how are we dealing with age distribution related disease occurrence? Is that your question?
No, it's more like, are you focusing on the step of recognizing that there is the disease?
Yes, recognizing there's a risk of a disease. That's what we are actually trying to do.
Okay, and then you basically just provide the data for another...
Correct.
Like
the goal of health predicted AI is actually to provide the preventive insights to them first, so that they can consult their healthcare professionals, people like me, people like doctors, so that they can get the continuation of advice accordingly. Because at the end of the day, healthcare, AI is not going to replace healthcare. There's a need for both to work in parallel. And that's why coming as a clinician, myself, and also as a technical someone who's trained in software engineering myself, sometimes I find it hard to actually juggle between these two worlds. But to answer your question in straight, this tool is meant to provide preventive insight. Then patients or caregivers will use the data and speak to their healthcare professionals to get the medical advice. We are not trying to replace medical or healthcare professional, because I am a medical professional myself. Yeah, does that answer the question?
Yes.
Yeah, thank you. Yeah, please help to do our survey for those. We have really 10 GitHub limited edition pins to Kim. My manager is at the back. Yeah. Any other questions? Or?
Any other questions? No? Yes? No? Thank you, Melvin.
Thank you.
Yeah, this is the last session of this track. So thank you for coming to FOSSASIA.